Hi, in today's video I'm going to be covering a new project that I've created called FreeBSD Cuda that enables Cuda support on FreeBSD using Podman containers. On FreeBSD we have the Nvidia graphics driver, but we don't actually have official support for Cuda or the Nvidia toolkit, container toolkit to work with containers. And basically what this means is there's a lot of Linux applications that require Cuda that haven't been possible to run on FreeBSD, such as Python applications that use Cuda, with Python torch, such as WhisperX, things like Comfy UI, Stable Diffusion. So what I've done is actually invented a completely new method of enabling Cuda on FreeBSD using Rocky Linux Podman containers. And what I'm going to do is actually describe the project to you, show you how this works, show you how to get Podman set up on FreeBSD, and explain how I invented this method that enables Cuda support on FreeBSD. So let's have a look at the project overview. You can run Linux command line and GUI applications on FreeBSD with full Nvidia Cuda hardware acceleration. And the way that this works is it mounts the Linuxulator libraries, which are actually Rocky Linux 9.3 libraries from FreeBSD into the Podman container. So you don't need to install the Nvidia driver into the container. And that was something I was previously doing in another project I created called DaVinci Resolve in a Rocky Linux jail on FreeBSD. So there's no Nvidia driver installed in the Podman container. It works by mounting the Linuxulator libraries from FreeBSD into the container. And what this means is when you upgrade the driver on FreeBSD, Podman will automatically pick up the new driver. What we also have is Wayland and X11 and PulseAudio pass-through, and it's using Pipewire Pulse with the PulseAudio socket. And what this does, it displays graphics and routes the audio through native FreeBSD sockets mounted inside the Podman container from the FreeBSD side. So we have zero latency, full hardware acceleration for video and audio. We also have persistent storage for files, so settings are retained when you stop the containers. So what this means is, for example, I have Firefox with hardware accelerated video and Widevine DRM support for encrypted videos, and these settings are stored on the FreeBSD side so that when you stop the container and then restart it again, all your settings in Firefox are preserved, such as your browsing history, your extensions, bookmarks, all that kind of stuff. We also have directories mounted from the FreeBSD side into the container for file access. So for example, again, with Firefox, what we can do is we can mount the downloads directory from FreeBSD into the container so that you can actually upload and download files with the version of Firefox running in the Podman container. Also, we have GUI Applications launched with a desktop entry on FreeBSD. So what this means is, rather than you having to use the command line to start up a GUI application, I have a method where I create a desktop entry that calls two scripts, wrapper-freebsd and wrapper-podman. And what this does is this actually starts up the container if it's not started, and then it launches the application inside the container using the Wayland or X11 sockets and the PulseAudio socket for audio. So what I've done is actually create 4 pre-configured applications that you can download and install. So what I've got is Firefox with hardware accelerated video and Widevine DRM support. And as I said, we have persistent storage and the downloads directory mounted from FreeBSD into the container. We also have ffmpeg with hardware accelerated Nvidia nvenc encoding. We have WhisperX audio transcription with Cuda acceleration, and we also have Ollama with working with Cuda, so that it's not using the CPU, it's using the GPU. On FreeBSD, you can install Ollama, but what it does is it uses Vulkan, which isn't actually as fast. So what I'm going to do now is have some tea, wet my whistle, and take you through this and show you the Podman containers that I've created, and then how you can actually set up the project, set up Podman, and explain how it all works. So another thing to note is I've built this project to be future-proof, so that we have categories of applications, and I've also created a git ignore for a custom directory so that you can build your own Podman containers without causing any errors when you do a git pull. So what I'm going to do first of all is take you through the applications that I've got one by one. So what I'll do is actually start with ffmpeg. What I'm going to do is we're going to come into Podman FreeBSD Cuda. Now I'll explain how the structure of the project is set up, and you're going to want to set up the directory structure that I show you here, because some of the scripts like the desktop entries rely on an absolute path to files inside the project. So I'm inside the project now, and what we have is the README, the base build, which I'll cover when I explain the project. Then we have the containers. So if I come into containers, what I've done is actually created different categories for applications, as opposed to a single long list of applications, which makes it easier for you to manage and go through stuff. So what I'm going to do is come into scripts, and we have ffmpeg. So I'm going to come to ffmpeg, and we have a look at the directory structure here. What we have is a .env file, a Docker file, a make file, a bin directory with scripts, a compose.yaml, and dot files. The dot files is the persistent storage for the settings inside the container. So what I'm going to do is run doas podman compose up-d. That starts up the container. And what I need to now do is actually come into here and enter the container. Now, the interesting thing about this is what I've done is actually set this up so that the user in the Podman container is the same user on the as on the FreeBSD host, and that is done using a make file that gets your user ID and your username and some other settings, and it creates a .env file which is used with the compose.yaml file. So when I enter the container, you can see I'm now in the container, and I have my bin directory. I've got a temp directory which is used, it's the equivalent of /temp, and I'll explain why we create a separate temp directory. If I come into video here, what you'll see is we have my current recording. We've got demo, OBS, and tech video. So now if I come across to the FreeBSD side, come into video, you'll see we have exactly the same files. So what you'll notice here is my username. Okay, so this is the FreeBSD side. This is the Podman container. I'm inside the Podman container now, and you can see I have mounted the video directory from the FreeBSD side into the container, which allows me to access files. If I come into CD, if I CD into demo, what I have here is Agent 327 Operation Barbershop, which is a Blender open source movie that has no copyright issues. So what I can do is actually play this video. So I'm going to play this video with ffplay. And what it's going to do, hopefully, is open the video and play it with audio.
This is 327. I'm going in.
Good luck, Agent.
So what I'm doing, I have the Wayland socket and the PulseAudio socket mounted from FreeBSD into the container, and that's what allows the graphical interface and the audio to come out, and it's using hardware acceleration, so we have perfect video even though it's running in a container.
Hello. I was just admiring the art.
Okay, so I'll stop that there. So what I've shown you there is how we can have hardware accelerated video playing using the Wayland and PulseAudio sockets. What I'm now going to do is actually execute a script that will trim this video, and it's going to use nvenc hardware acceleration. So what I have is a series of scripts. So if I come across to github.com and come across to my profile, what you'll see up here is ffmpeg Rust scripts. And these are a set of scripts that I created. And what we have is actually binaries for different operating systems. But the important thing is I have versions for FreeBSD and versions for Linux. And the Linux version has support for nvenc hardware accelerated encoding. And what I've done is I have, if I just come back out. Okay, let me show you. Containers, scripts, ffmpeg. What you'll see is the bin directory here. What that is that is the ffmpeg Rust scripts, and the bin directory is mounted from the FreeBSD side into the container, so we have access to the scripts. So what I can now do is run trim clip -h, display the help. And what I'm going to do is give it a start time, the input file, and the number of seconds after the start time. So trim clip start, and I'll just do a 30-second clip in to 30 seconds. And what you'll see here when I press return is it'll say using hardware acceleration. And what it's doing is it's trimming this clip to a 30-second clip. If I now run ffmpeg-i agent, the new file, you have a look down here, you'll see hevec nvenc. So that is showing you that this file has been encoded using the Nvidia nvenc encoder. And I can play that video. Okay, right, so that's the first thing, is ffmpeg with hardware accelerated encoding. So I'm going to come out of that, doas Podman compose down, stop that, come back here. So that is ffmpeg with hardware accelerated nvenc encoding with no driver installed in the Podman container. The Podman containers are built using Rocky Linux 9.3, which is the same version as used in the Linuxulator. So we have maximum compatibility between the container and the Linuxulator. And as I said, the method that I've invented basically bypasses all the virtualization, so you don't have to virtualize stuff and have an overhead. So what I'm going to do now is I'll see if I can get WhisperX to run, and I may just use that short clip that I created. So what I'm going to do is actually come across to my notes here. Python, WhisperX. So Python, WhisperX, doas, Podman, compose up-d. So another thing I should mention is what we have on FreeBSD is what's called rootful Podman. Linux has what's called rootless. So the difference is, as you can see, on FreeBSD you have to run Podman as root, okay? However, that does not mean that the applications inside the containers are running as root. What I'm doing is I'm setting it up so that the container runs as a non-root user. It runs as your user, okay? So if I just come back, if I come back into demo, that demo folder I just showed you, what you'll see is the file that I created using that trim clip script is owned by my user on FreeBSD, okay? So what I'm going to do is start this up. I've started this up and I need to enter the container. So what you'll see is doas podman exec it-u user. So that's going to run as my user. And what we can see here is we're actually in a virtual environment. So this is the WhisperX virtual environment. And now what I'm going to do is actually run the Python check for Cuda. Okay, hang on, let me just grab that text. So what this is this is a one-line bit of Python, and what it does is it imports the torch library, and what it's going to do is print Cuda available, torch is available, print the device. There you go, Cuda available true. And it's listing my graphics card. Okay, so that's proof that we have Cuda working. Now, the reason why this is important is because there are a lot of Python applications that require Cuda that haven't been possible to run on FreeBSD previously, but now they are. What I'm going to do is actually run WhisperX, and I'm going to come into the demo folder. So for the ffmpeg container and for WhisperX, I am mounting the video directory, and this is actually set up automatically by using a make file that creates a .env file. And what it will do is it will analyze your system, get things like the xdg runtime directory, dbus settings, your username, your ID, and it also checks if you're running X11 or Wayland. And what it also does is it checks which directories that you have set up for different things. Like it checks if you've got like videos or videos sort of up and lowercase. So typically with desktop environments, they will create default directories, you know, like desktop, documents, downloads, video, pictures, that sort of thing. So we're coming to the demo now. What I'm going to do is actually rename the clip just to clip. I'll call it input.mkv. Input.mkv. And what I need to do is come across to my code here. Okay, so I can't remember if I need to actually set this to a WAV. Okay, so I think that WhisperX can actually transcribe video files, and you don't have to convert them to audio files. So let's check out if my memory is correct. So WhisperX, input.mkv, bang that in there. And this is going to be using the GPU, so apologies if that sort of interferes with the audio while I'm recording with OBS Studio. I need to give it a second or two. As I can't remember if you can use video files or if you've got to use an audio file. I said this may be taking a little while because I only have 4 gig of VRAM on the system, and I'm using it to record OBS Studio at the same time. Oh no, there we go. So the section I chose, the 30-second clip I created, didn't actually have a lot of audio. And what I'll do is I'll take you through the WhisperX setup, but what this is it's audio transcription with speaker diarization. Okay, so it will actually say speaker 1, speaker 2. So what you'll see here is we now have these files. We have the SRT, subtitles, tab separated value, text file, VTT, and JSON. So it should actually pick up the subtitles. So what I'm actually going to do is I'm going to play this on the FreeBSD side. Okay, so I'm on FreeBSD now. See, exactly the same thing. If I play with MPV input.mkv, because the generated subtitles have the same file name but a different extension as the video, MPV should automatically pick this up. And I think I don't have this set up. Actually, I don't have this set up to. Okay, I haven't set up audio capture for the FreeBSD side. So let's just check if it works with ffplay. Can't remember if ffplay automatically picks up the subtitles or not. Let's pour some more tea.
This is 327.
Okay, so ffplay is not actually picking up the subtitles. So I will actually play this with MPV, but I haven't set up the audio capture. I'm just going to do it to show you that the subtitles are actually working. So you say you can't hear anything because there you go. So I think the subs were actually a bit off there, and that is probably because I'm recording with OBS Studio at the same time as using WhisperX. So I've got two things using the GPU at the same time. And as I said, this is a Dell XPS 15 from 2019 with a GTX, was it 1650 card with 4 gig of VRAM. So not much I can do about that. But you can see it actually created the subtitles. But as I said, because I'm using the GPU with OBS and WhisperX at the same time, that is probably why it got the timing a bit off. But you can see, as I said, I scroll back up here. As I said, when I ran the Python one-line check to see if it could access the GPU and Cuda, it returns true. And so that proves that Cuda is actually working with Python Torch. So what I'm going to do is I'm going to exit that container. Doas Podman compose down. So just need to have some more tea. Yorkshire tea, of course. So what I'm going to do now is actually show you ffmpeg with hardware accelerated nvenc encoding, and not Firefox with hardware accelerated video and Widevine DRM support. So what I'm going to do is I'm going to switch across here. I'm going to run Firefox Podman. Okay, it opens a lot quicker than that, but as I said, because I have a old GPU, do you know what I mean? It's difficult for me to record stuff and demo it at the same time. So what you can see here is Firefox running in a Wayland window with PulseAudio set up, and we have persistent storage. If I, for example, if I do open file, okay, what you see is I have downloads here. Okay, downloads. If I switch across back to FreeBSD and come into the downloads folder on FreeBSD and do touch file, okay, and I need to come back out of this one into browsers Firefox. No, that doesn't make any difference. Right, so if I come into here and do, this is Firefox in the container, and I come to home and I come to download, you'll see file. Okay, that's the file I just created. So that's showing you that the downloads directory from FreeBSD is mapped into the container so that you can download files or upload files from that downloads directory. Now, the other advantage of this is it's actually makes this more secure as a browser, because it only has access to that downloads folder on the FreeBSD host, not the rest of your system. So what I'm going to do now is actually see if I can I'm going to play the intro of Bill and Ted's Bogus Journey, and hopefully this will work. And what I'm going to do is just play the opening seconds. And what this is a DRM encrypted video. Now I'm going to stop that there. Okay, but this is a YouTube free with ads video. Okay, and those are actually DRM encrypted. So this shows you that we actually have Widevine and DRM working, hardware accelerated video, and the audio working. So what I'm going to do is I will actually have to go through all these things and explain how this is set up, but this is an initial demo of the containers in action. So what I'm actually going to do is I'm actually going to stop that and run doas podman compose down. So as you saw, I was launching Firefox in the container using a desktop entry on FreeBSD, just as if it was a native application. Okay, as I said, what I have is two scripts that work with desktop entries called wrapper-freebsd and wrapper-podman. And what these do is these are scripts that are customizable with options to launch different applications in different containers. And those work in conjunction with the desktop entry. Now, next thing is Ollama with Cuda. So what I'm going to do is right here, cd AI Ollama doas Podman compose up -d. Okay, and I'm going to come across to my notes. Ollama, start the container, enter the container. Okay, so I'm now in the container. Now, what you need to do is actually run Ollama serve. Now, because I have a older GPU, which is a Turing Nvidia GPU, what I actually have to do is run this second bit of code down here. So normally, if you've got a newer GPU, you would just run Ollama serve in the container we have just started. And that will use Cuda version 13. However, because, as I said, I have an older GPU, what I need to do is run Ollama LLM library equals Cuda underscore v12 Ollama serve. Okay. And what you'll see down here, listening on 127.0.0.1, and you're thinking, mate, that means I can't access it from FreeBSD. It's just running in a container. However, what we're doing is we're actually setting up host networking. So it actually uses the networking on the host. And what that means is if I switch across here and run Ollama list, bang, you see. So you understand this. We are in a Podman container here that is running Ollama version 24, which is much newer than is available on FreeBSD. I am now on the FreeBSD side, so tmux tab version 3 is Ollama running in the container. Tab 1 here is me on the FreeBSD side. And as you can see, I can now run Ollama commands in the terminal, and it is using the version of Ollama running in the Podman container. So let me run this one, which is particularly small. So Ollama run. So I'm just actually choosing a really lightweight model here. And as I said, this is much quicker when you're not recording with OBS Studio at the same time. So what I can do is say, write a simple hello world shell script. You can see how fast that's going. And some of these, so like these smaller models that I'm running actually do kind of get confused. So I'm just going to stop that there. So because, as I said, I only have 4 gig of VRAM, this being an old computer. I can't run massive models, and these smaller models tend to be a bit thick and repeat themselves. Have some more tea. But as you can see, I'll just buy that. I'm going to stop Ollama here. Okay. And I'm going to exit. Doas Podman compose down. And I'm just showing you this stuff quickly because, as I said, there's a high likelihood if I were to run anything heavier that it would just crash OBS Studio. But what you've just seen is Ollama running with Cuda in a Podman container, directly accessing the GPU on FreeBSD, and that on the FreeBSD side, because I am using host networking with Podman, what that means is that it can actually see Ollama running in the container. And you don't just have to use the terminal, you can use any front-end application for Ollama on the FreeBSD side, so something like OpenWebUI, or I use Emacs with GPTel. So any front-end application you want to use on the FreeBSD side will automatically pick up Ollama. Okay, so that was a quick demo of the 4 pre-installed applications. And as I said, what I have done is I've set up the project so that you can create a custom directory where you can use the examples that I have created to create your own Podman containers. And because I have added the path to the custom directory to the gitignore file, you won't get any errors pulling down the latest update for the project. So what I need to do is actually go through the initial setup of this so you can actually get started. So first of all, what you need to do is actually follow the Podman install instructions, which I have listed down the bottom of the file. And what I'm going to do is actually sort of do this. I'll take you through the Podman setup. I've actually done a complete video on how you set up Podman on FreeBSD that you can refer to step by step. So what I'm actually going to do is actually come down to the Podman settings. So the Podman install. So actually getting this set up isn't too difficult, but there are some things you actually need to know. Setting up various things like PF rules, devfs rules, and things that I'll get into. So the first thing we need to do, obviously, is install Podman. And what you'll see here is I'm using doas for all of these commands, and I'll explain why. The reason why we're going to be using doas is because, as I said, Podman containers on FreeBSD are what are called rootful containers, and they must be run with doas. So what I've done is created a doas configuration file that allows you to run any command without being prompted for your admin password. And the reason why we want to do this is because we are using sort of desktop entries and things to launch Podman containers, and you don't want to have a terminal popping up prompting you for your admin password. So first of all, what we need to do is install the following packages. So doas pkg install podman-suite, py311-podman-compose. And this is used with compose files, which are configuration files that I'll show you that are actually used to initialize the container. So the Podman suite is a meta package that installs additional packages for you like Builder and Scopio. So that's the first step, install the packages. Okay, the next step is we actually need to edit our fstab. So what we need to do is actually have devfd set up. So this is how you mount devfd, but what we need to do is actually set that in our fstab so that it is permanent. So if I come across to etc fstab, what you'll see here is I have two things. I've got, you need proc for Linux, because as I said, we're using the Linuxulator. So what I'm also going to do is actually link to my configuration files for the root setup of my FreeBSD system so that you can compare them to yours and simply copy the code. Obviously, you don't want to copy the device up here. So what we have here is Linux procfs read write 00, and for Podman we want fscript devfd fdescfs read write. So these are the two options that you need to enable in your fs tab. Okay. Okay, and I will amend that so that it includes proc as well. Okay, so the next thing is you actually need the Linux compatibility layer set up. And this is the Linuxulator. And what this does is this actually installs Linux libraries from Rocky Linux 9.3 in /compact. So what you need to do is actually run doas sysrc linux_enabled equals yes, and start the service and load the 64-bit Linux kernel module, and run doas kld load Linux 64, and then to make sure that this boots, this is set every time it loads up, you add doas sysrc kld_list plus equals Linux 64. So if we have a look at etc. Is it? Let me just check. Oh, wrong file. Loader.conf. I think it's etc. rc etc. rc.conf, and okay. Let me just come down to the KLD list. Okay. So this is etc. rc.conf, and this is what is called the KLD list. And because we're using Nvidia, you're going to want to have these things set up, and you're going to want to put them in this particular order. We've got Nvidia-mode set, Nvidia-DRM. This one is particular, this TU10X-FW. I believe that may be specific to my card, so you may not need that. Then we have Linux 64, i915KMS, which I think is related to Intel, and you can ignore these. This is the for Fuse. Mac priority is actually an audio setting that you will want to enable so that it actually reduces the latency on the audio. So let me just come through the things you're going to want to have set up. You'll want to have PF firewall set up because that is used with Podman to NAT the networking. It's a good idea to have NTP set up. And the KLD list, I have seat enabled equals yes because I'm using Wayland. You're going to want to have dbus enabled, and the reason why you want to have dbus enabled is because, for example, with the Firefox container, because it has access to dbus, the desktop notifications from websites will work and show up on FreeBSD. We have Linux_enabled equals yes, and this is again required so that we set up the Linuxulator. And this is actually required for the Nvidia drivers because the libraries are actually Linux libraries and installed in compact. Virtual OSS, you can ignore that. Audio jack. Okay. The other thing we have is devfs system rule set local rules, and you're going to want to have this set up because what we're going to be doing is using what are called devfs.rules, and this allows you to manipulate the devices and change the permissions on the devices and unhide them for Podman from the FreeBSD side. So you do need devfs systems rule set up because we are going to be using that. So there are lots of pieces to this setup, and actually creating the project, figuring out how all this works, getting it to work, creating the project, designing the project, writing the documentation, doing the video, doing the flipping description for the video is a lot of work, and sometimes it's a real pain to do the documentation, and there may be some things I forget to actually document. So that's why I'm recommending you go through this video step by step, so that if there's anything that slipped my mind during writing the documentation, I'll bring attention to it here. So that is something I'll need to do, mention in the documentation, is that you need devfs system rules set up in your rc.conf. So it's acclerated.rc.conf. Okay. So, okay. And at the bottom, what you need is Podman _enabled equals yes. And I believe I refer to that in the next section, the documentation. Okay. All right. So the PF. So we need to set up the PF firewall. So as I said, I showed you the options that you need to enable in your rc.conf, and I'm just actually set up here. So what we need to do is have PF enabled, and if we have a look in the bootloader.conf, I believe I've got that set up. Oh, I thought I had. So maybe that's a mistake on my part. It's not bootloader.conf. Okay. Okay. So note fix error. So it is actually my bad. It is not PF. Okay. It is in acclerated.rc.conf. So I'll fix that error. PF, yeah, PF firewall. Okay. So in your acclerated.rc.conf, what you need to have is PF _enabled equals yes, and that is for the PF firewall. So let me just fix that while should be doas sysrc, I think. So let me just fix that as I go along. So that'd be, let me just check that's right. That should be correct. Oh. Let me just check the syntax is correct. I think that should do it. Okay. So what I'm actually going to do is actually come across to the pf.conf and show you how that's set up. And once I go through this section on setting up Podman, I will actually go through and show you how we can set up the project and how the project is organized. What I'm going to do is actually link to my pf.conf. Now, there is a pf.conf.sample file for containers, and it looks like this. We have v4 egress, if, v6 egress or if. These are IPv4 and IPv6. We have these nat commands, anchor and table. Okay, so what we need to do is actually edit our pf.conf, and if you've worked with pf.conf, PF firewall, you'll know that the order of the commands is critical. and you can't just put them anywhere. They have to be in specific sections. So what I have set up here, first of all, that I covered in a previous video, is what is called a LAGO interface. And what that is a virtual interface that combines the Ethernet and Wi-Fi devices into a virtual interface, so that when you switch between Ethernet and Wi-Fi, it will actually, the firewall will continue to work. Because if you have the firewall set up using your Ethernet device and you change to Wi-Fi, the PF firewall will stop working, and you would have to stop it, edit your configuration file, change it to Wi-Fi, restart PF configuration. And so what this does is, this means by using this virtual device, you don't have to do that. So I did a video on this, and I would strongly recommend setting this up, because it will make your life easier. What we have down here is the v4 egress and the v6 egress. And as you can see here, these are marked Podman. And what these do is these correspond to the default network interface, okay? So if I come across here and run if config, what you'll see here is I have my WLAN 0, the Wi-Fi. I have UE0, which is my USB Ethernet adapter, and then I have LAGO. And what this is that is it's a virtual interface that combines the Ethernet and the Wi-Fi. So what we have to do is actually set this option to be equal to your default network device, okay? So you're not using LAGO like I am. You would have to set this to whatever your default network device is, whether it's Ethernet or Wi-Fi. What we have down here is stuff of VPNs, TCP, UDP, and let me come through back to the notes. So what you'll see here is we have these sort of 3 blocks of setting. The first one here, the v4 egress and v6 egress. Then we have the NAT commands, we have the anchors, and then we have the table. And these have to be put in specific sections in the PF configuration file. So what you'll see here is, if I scroll down, now the other important thing is actually this section here. Set skip on LO0 CN1 CNI-podman 0. This is essential. This is what actually allows the networking to work. Okay, so as I said, it's difficult to come up with the idea, to get all this working, you know, test it all for all these different applications that I've just shown you, and write the documentation, you know, do the video, all that kind of stuff. And this is when my lighter decides to run out of gas. I know I've still got a bit in there. Okay. So again, what you'll see here is this section. Set skip on LO0, that's localhost, and CNI-podman 0. So you need to put that in. And so that I have put my own PF configuration file in the documentation, but there are things that I need to actually bring your attention to that I may have missed in the documentation. And that's why I'm going to actually link to my setup, so that you can actually see, okay, this is a working setup. I need to copy these options. What we have next is Podman NAT. So what you see here is NAT on v4 egress interface, and that corresponds to the section up the top. Then we have the Podman anchors and the table down here. Okay, so we have the v4 egress up here. We have the set skip. we have the Podman NAT and the Podman anchor, and then we have the rest of my settings down here. Okay, so as I said, I would advise you to just steal my code. It's the easiest way to get set up is just copy my configuration files, and that way you'll know that you've got everything set up to go. So, all right, let me come on to the next start. Once you've changed the PF, you're going to need to restart it with doas service PF restart. Now we're going to be using ZFS, and what you need to do is actually create a ZFS dataset for Podman. So what we're doing here is doas ZFS create -o mount point equals var db containers z root containers, and this is the path that is defined in the Podman configuration file. So you need to set up this exact same path, otherwise you will have to change the Podman configuration file, and that's on you to do. That's beyond the scope of this tutorial. So again, we create the ZFS dataset for Podman. What we also need to do is apply netpf filters underscore local equals 1. So that's doas sysctl net.pf.filter underscore local equals 1. And we set that permanently in our etc sysctl.conf. Okay, you can see that section there. And if I come across to etc sysctl.conf, what you'll see is down at the bottom I have this section net.pf.filter underscore local equals 1. Now, as I said, there are this is just getting Podman set up, so it may seem a bit overwhelming. If maybe thinking, oh, it's too much work, it's not too bad to get this set up. Okay, it doesn't take that long. It's just I'm actually going through and pointing out all the various things that you need to get set up for the firewall and networking. We then actually enable Podman, and as I said, we did that. We can do that with doas sysrc podman underscore enabled equals yes, or you can manually edit your etc rc.conf. Okay, and you will see there we have podman underscore enabled equals yes. Now the next thing that we need to do is set up what are called the registries, and these are the locations where Podman will pull containers from. Okay, so when you do a Podman pull, it will pull from these registries that we enable in this file here. So we need to edit the registries.conf, and we do that with doas vi /user /local /etc /containers /registries.conf. And what you need to do is append the following code here. So what you'll see here is unqualified search registries equals docker.io, gua.io, ghcr.io, and what you'll see down here is listed the registries. So registry location docker.io, qa.io, and ghcr.io. So these registry sections correspond to the unqualified search registries that I've just shown you. So what I'm going to do is open that file, user local etc containers, user local etc containers, registries.conf, and what you'll see here is this is the default file, and at the bottom I have appended that code that I've just shown you. And let's see if we can get the lighter working again. Okay, so as I said, you have the unqualified search registries, which are the locations that Podman pulls from, and we have these 3 registries sections here that correspond to these sections up here. Make sense? Right. Okay. So we've now set up the registries where it's going to be pulled from, and what we're going to be doing in this section here is actually creating a ZFS dataset for the project And what we're going to be doing is we're going to be creating a data set that is actually going to be mounted to Podman in our home directory. Now, the reason why you want to do this is because this allows you to roll back, have everything snapshotted correctly. And in this example, what I'm doing is I'm using my username here. So what you need to do is change my username for your username. So we run doas zfs create zroot /home /your username /podman. And then what we need to do is change the permissions on that directory. As you can see here in this example, I'm using doas chown -R my username /home /my username /podman, and that corresponds to this Podman directory here. Okay, this is the Podman directory in our home folder. So that is why, because we're creating what this does is it creates the mount point automatically. Okay, but because we're running as doas to create the ZFS dataset, it will be owned by root. So that's why we need to change the permissions. Now, I hope if I spelt things correctly, but there you go. As I said, you can just create a directory, but as I said, the configuration for Podman does expect a ZFS dataset. All right. So you might as well create a ZFS dataset for Podman. So the next thing that we're going to be doing is setting up doas so you can run Podman without being prompted for a command. Now, this will allow you just to run Podman without being prompted for your password, but what I would actually recommend is if I come to user local etc doas.conf. Right, so what I would recommend is actually setting up doas so that you can run any command without being prompted for a password. And this is useful because, as I said, we have things like desktop entries that call scripts that require doas, and it will be difficult to create lots of doas rules to catch everything. So what we have here is the user local etc doas.conf, and what we've got here is permit user. So the order of commands in the doas configuration file is essential. Last rule wins. So first of all, what we have is permit, keep environment, set environment, path, and then your username. So what this does is this keeps the environment and the path when you're using doas. What we have down here is allow root to switch to our user. So this allows root to switch to our user, basically. So permit no path, keep environment, set environment, path, root as our username. So wherever you see my username, replace it with yours. Then what we have is permit user no path. And what this rule allows us to do is run any command that requires admin privileges prepended with doas, and it won't prompt us for the password. And as I said, this is something that you do want to set up. It's not really a security issue, unless you leave your laptop lying around open, which you're not stupid enough to do. But this is required because we are running scripts and desktop entries and things like that to launch containers, and you don't want to be prompted for a password when you do that. So what we have down here on the next rule is this is how you can actually permit a particular command to be run without requiring a prompt. So you can see here, permit no path, keep environment, username, command, user local bin podman. And what this means is this will allow you to run Podman using doas without being prompted for a password. And at the end, what you want to have is permit no path, keep environment, root as root. And this is essential so that doas switches properly to root. Okay, we're getting there, don't worry. Now, The next crucial thing is devfs.rules. And let me see if I can get one on the go, so to speak. I've run out of tea, some cold tea. I will take you through and explain how the project works, okay, and how we actually enable access to the GPU from inside containers. And as I said, Nvidia gives us the Nvidia drivers, but it doesn't give us Cuda, and it doesn't give us what's called the Nvidia Container Toolkit, I believe it's called. And what that does is that allows applications running in Podman containers access to the GPU. So what we're doing here is we're not only getting Cuda working and everything, but at the same time we're sticking it to the man, in this case Nvidia, with billions of dollars, who can't be bothered to actually provide us with Cuda and the Nvidia toolkit. We're doing it ourselves. So that's a nice bonus. So this is essential, and this took me a long time to actually work out. What I'm going to do is actually come across to my etc devfs rules. Okay, it's actually better syntax highlighting in here actually. Okay, so what we've got is the local rules, and I'll need to make a note about the fact that you need to set up the local rules in one of the configuration files. So what we've got here is local rules and devfs rules jail 4. Okay, so the local rules are settings that apply to the FreeBSD side. The next sections are actually rules that apply to the Podman containers. Okay, so first of all, what we have here in the local rules, as you can see here, we've got DA, DRR, DIR, DRM, input, input event, Nvidia. And what you'll see here is add path, and some of these have got a wildcard, the asterisk. What that means is that that will match multiple devices. And then what we have is mode 0666, group, and then we have things like operator, group video. And what these do is these change the permissions on the devices on the FreeBSD side and allow access from other groups. So by default, the Nvidia drivers are owned by root, okay? And what we're doing is we're changing the permissions to 0666, not 666, 660. And what this does in combination with the group command is this will relax permissions so that we can actually access the GPU from within the Podman container. And the way that is done is actually with group permissions, which I'm going to take you through. So this is essential. What you see here, the Nvidia, if I come across and run ls-l dev Nvidia asterisk, what you will see here is, so you got user, group and owner. So user, group, owner, and what you'll see here is root and video, okay? And that is set with this rule down here. You need all these rules set up. So what you can see here is that has changed the permissions so that the video group has access to the GPU. Now what you see down here is devfs rules underscore jail equals 4. Okay. And did you know that Podman containers on FreeBSD are actually jails? And the reason why this is important is because we can use jail rules that apply to the Podman container to allow access to the GPU. what you'll see first of all here is add include devfs.rules unhide basic, add include devfs.rules unhide login, and then what you'll see is add path mixer unhide DSP dir DRM Nvidia and speaker. Okay, and so what this does is this unhides the devices from FreeBSD so that the Podman container can see them. Okay, this is essential so that the Podman container has access to the GPU. Okay, so there's etc. devfs.rules. All right. Now you got to this stage. What you should be able to do is run this command to print out a hello world. So if you've been following along, this is the test to pull down a hello world container. And as you can see, it's pulling from docker.io, and that is the repository that we set up in the registries.conf file. So once you've got to this stage and it's printed this, you're good to go, right? So let me just make a note of the devfs rules note add devfs rules to config, just so I can remember. So once you got to this stage, you're good to go and you're ready to move on to the project. Now, the reason why I've actually gone through it this way is because there's nothing worse, in my opinion, than actually someone telling you how to do something and missing out a load of the steps to actually get there. It's incredibly frustrating. And that's why I'm kind of going into this stuff in depth, so that you can follow along as you're going through the setup. And I'll try and put timestamps or chapters for the video so that it makes it easier for you to jump to the correct section as you're going along getting stuff set up. So, as I said, once you've got to this stage, you've got the hello world set up, you know that Podman's working, you can then actually move on to getting the project set up. So, although that may seem like a lot to get this set up, you've got to bear in mind that that is nothing compared to how much work was actually involved in figuring all this out. As I said, that this is a completely new technique that I've invented that is based on work that I've done with running DaVinci Resolve in a Rocky Linux jail several years ago. So what we're going to do is actually come across to the initial setup, okay? So what we have done is we have followed the Podman install instructions. So what we can do now is actually move on to the next section, and that is pulling down the repository. So what you want to do is come into cd Podman. Okay, this is the ZFS data set that we have created and changed the permissions on. And this is where we are going to download the project. As you can see, FreeBSD-Cuda. Nice and simple, does what it says on the tin. So what we need to do is run git clone and the path to the repository here in that directory, and that will pull down the project so that you're ready to go. So I need some water or something. Let me just grab a glass of water. Yeah. Not as good as tea, mind you, but there you go. So we cloned the repository. Now what we're going to do is actually take a look on the actual setup that is required. So there are various things that you will need to install on FreeBSD. So what you need to do is actually install Pipewire, PulseAudio, and PavU control. Okay, and the reason for this is because obviously Linux uses Pipewire and PulseAudio. So what you want to do is run doas pkg install Pipewire PulseAudio pavview control. And pavview control is the volume control application for PulseAudio. And this is actually used. There is a difference between GUI applications and command line applications, which I will get into. What we have here is the PulseAudio config. So let me actually come into the directory structure here. So what you'll see, you've got the README, the base build and containers. And if I show hidden files, what you'll see here is we have a gitignore file. And what this does is we're going to be using make files to create a .env file, which will be used with compose.yaml files with Podman. And these files will contain your username, your user ID, XDG settings, dbus settings, Wayland settings, mounted directories. And what I'm doing is actually using a make file to create the .env files and using the gitignore file to ignore them. And the reason for that is because everyone's going to have a different username and ID. And so by doing this, what it means is you create the .env files, check everything's okay, and they won't be tracked by Git. And as you can see down here, we've got containers custom. So we have a containers directory that has various categories here. You can see browsers, Python scripts, and the custom container, a custom directory, which isn't included in the project that you would create yourself, is where you would create your own Podman containers, and they won't be tracked by Git, so that you can do a Git pull and not have any issues with Git telling you, oh, there's untracked files. You'll see here we've got things like bin directory, which is the bin directory that actually contains a script to launch Firefox, and we have dot files. So these are all set to be ignored by Git. So what I'm going to do is come across into, let me just set that to display that. So we got base build and we got containers. So base build, what you see here is we've got 4 directories. We've got assets, base image, dummy-uvm, and uvm_io ctl_override. If we come into assets, so we're in the FreeBSD Cuda directory, base build, assets, and what you'll see is applications, PulseAudio, and scripts. So if we come into the PulseAudio directory, what you will see is a makefile and a default.pa. So what you need to do is, the way that this works is we actually launch PulseAudio on FreeBSD, and using the default.pa file, what it does is it creates a PulseAudio socket in /temp called pulseaudio.socket. And this socket is mounted from FreeBSD into the container, which then has what's called a client.conf file that points to that file, so that applications launched, either command line or GUI applications launched in the container, will then look for that PulseAudio socket and route the audio through it and out from FreeBSD, which is running Pipewire Pulse, but it's using the PulseAudio socket. Now, there's 2 ways you can set this up: the easy way or the hard way. You basically, what you do is, if I come into the FreeBSD Cuda, base, assets, PulseAudio, what you'll see is said we've got the make file and we've got the default.pa. So all you've got to do is go into that directory and run make. So if we have a look at the make file, what it does is it will create a .config pulse directory on the FreeBSD side, and then create a default.pa file in there with the following code. Okay, If you already have a default.pa file in your PulseAudio configuration directory, you will need to do this manually, because otherwise the makefile will see that one exists and stop. So option 1 is just using the makefile. So you come into FreeBSD Cuda base build assets PulseAudio, just run make, and what that will do is that will create .config pulse, and what you'll see here is default.pa, and what you'll see here is we include the default.pa and override it. So include the user local etc pulse default.pa, and what we're doing here is we're creating the PulseAudio socket, and we're doing that with if exists module esound protocol unix.so load module esound protocol unix ndif, and then load module native protocol unix socket equals temp / pulseaudio.socket. And if I come across to temp, you will see that file there. So this is the PulseAudio socket that is actually created, and for Firefox the desktop entry will actually automatically start PulseAudio for you on the FreeBSD side if it's not started already. If you're using command line applications such as ffplay, what you need to do is actually start PulseAudio volume control and keep it open. And what that does is that starts up PulseAudio, creates the socket and keeps it open, because by default PulseAudio times out after 20 seconds. So for command line applications like things like ffplay that I showed you in the ffmpeg container, what this will do is this will keep the socket alive, so that ffplay continues to work and pipe the audio out from the container into FreeBSD. All right, so that's the default.pa. So as said, you just come into base build assets PulseAudio, just run make, and that will create the .config pulse directory and then create the default.pa file. Okay. Or you can do this manually. You can run make dir-p ~.config pulse and then create the default.pa file with the following code. If you already have one, then simply append the code shown here into the file. Next thing that we have is what's called the wrapper-freebsd script. And this is used to launch GUI applications, and it works with the wrapper Podman script, which is installed in the Podman containers, and a desktop entry. So what you're going to want to do is copy the wrapper FreeBSD script to your bin directory. So you can see here I've provided the full path, which is Podman FreeBSD Cuda base build assets scripts wrapper FreeBSD ~bin. Okay. So if you're hang on, bin .zsh-env, what you'll see in my zsh-env configuration is this is how you set the path, and I'll I'll link to everything so you know how to get everything set up. So this is how you set up the path to include the bin directory, so that it's set up in your shell path, and scripts installed there will be picked up on the command line and in applications. If you don't have a bin directory and you don't want to create one, you can simply copy the script to user local bin, and you can do that with this command, but you'll obviously have to prefix that with doas cp ~/freebsd . And I'm going to need to take a slash. I could pause the video, but sod's law, I know something's going to go wrong if I do that. So 1 minute while I take a slash and I'll come back. So hang on a sec. Oh, that's better. That's one thing about drinking a gallon of tea a day. Right, so that is the wrapper-freebsd script. And I said that is used to launch GUI applications, and that works with the, come into local share applications. And what we have here that I'll show you when I get to the Firefox section, as I just have a bit more water, is we have a firefox-podman.desktop file, and that shows up in the application launcher, the Firefox Podman. And if I open this here, what you'll see is this desktop entry calls the wrapper-freebsd script, which I'll show you, and it uses these various options to actually start the container up and launch the application from within the container. Right, close that. Okay, so that's the wrapper-freebsd script. Okay, so that's the initial setup section. What we have next is the building the images. So the way that this works is we have base images which we then build other images from. So we just close this, come into here. So what you see here in the repository is base build. Okay, and if we come into this directory, what you'll see is the assets. As I said, that was the PulseAudio. We've got the scripts here, the wrapper-freebsd script. The wrapper Podman script is automatically set up for GUI applications, but I'm including it here so you have a reference to it. So we got the PulseAudio, the scripts, applications. So this is for Firefox. We got the Firefox Podman desktop entry that I'll show you, and the user.js file, which is used to enable hardware accelerated video in Firefox. But what we need to do is actually come across into base images. So FreeBSD Cuda base build base images. And what you will see here is we have two directories, Wayland and X11. So obviously these are configuration options for both Wayland and X11. So this project will work on Wayland and X11. I'm currently running Wayland and not X11. So I think I have got everything set up and working correctly for X11, but I haven't actually been able to try it, but it should be good. So what we need to do is actually build the base image. So what we need to do is change into the base image directory. And if you're using Wayland, what you need to do is change into the Wayland directory, and you'll see there is a Docker file. And in the X11 directory, there is a Docker file as well. So what you need to do is, in my example, I'm using Wayland. So you can see here, I have the Docker file. And now what I'm going to do is actually show you the Docker file. I'm going to do this for both of them. So come across here. Now all the files are formatted the same way for easy readability, fully commented so that you can easily scan through them, and they use a particular commenting system that I like, that I find easy to read. So up at the top we have file, Docker file, project, base image, Wayland. It says here Rocky Linux 9.3 from Rocky Linux 9.3, and what this is this is the base image that we are pulling from. So as I said, the Linuxulator on FreeBSD uses Rocky Linux 9.3. So we're using exactly the same image, and this is important so that we have maximum compatibility. Now, you don't want to use a different type of Linux like Debian or Ubuntu or something like that. And the reason for this is because we are mounting the Rocky Linuxulator libraries from FreeBSD into the container. And libraries built on different versions of Linux won't work on other versions of Linux. So that is why we are using Rocky Linux 9.3, and it actually works better than things like Debian and Ubuntu, which actually give you errors with systemd and things like that. So this is where we define the image that we're pulling from. So we're pulling Rocky Linux 9.3, and this will be pulled automatically using the registries that we defined. It will automatically pull, I think from memory, when you actually run this, it will sort of prompt you with a set of free choices like docker.io, qa.io, ghcr.io. You can just use the first one. So it will actually pull down stuff. And what you'll see down here is we've got arg, pass on the command line. We've got host UID and host user. And what these correspond to is actually your username and user ID on FreeBSD. And what we have down here is some settings for DNF, so that maximum parallel downloads, retries, and timeout. And what we're doing down here, if I just zoom out a bit to make it easier to read, is we are setting up DNF. DNF is the package manager on Rocky Linux. And what we're doing is Rocky Linux has repositories for non-free applications. It's a bit like PPAs on Ubuntu. And what we're doing is we're actually setting up, in the first stage, we are setting up repositories where we will pull the packages down from. Okay. And again, this is something that, required a lot of work, is we're actually installing ffmpeg. And what we're doing is, you can see, install ffmpeg with allow erasing. And what we're doing is we're running DNF group update multimedia set options, install weak dependencies equals false, exclude package gstreamer, exclude gstreamer, allow erasing, skip broken -y. The reason for this is because due to licensing and stuff like that, Rocky Linux, Fedora don't ship with non-free stuff. And there are GStreamer actually causes a sort of conflict with ffmpeg, so this is why we have to exclude it. Okay, next what you'll see is installing core applications. So what you'll see here is we're again excluding GStreamer, and you'll see we're installing all these packages here. And what these are packages that are required in the container so that it can actually work with Wayland using the Wayland socket. So we've got things like Wayland protocol, Qt5, Qt6. And what you'll see down in this section down here, create group and users. Now what this does is, this is another thing that took a lot of time to actually figure out. So what you'll see here is we're adding different groups. You can see here we've got group 44, video host, host ID, host user. What this is doing is host UID and host user correspond to the username and ID of your user on FreeBSD. You can see here Pulse host, Pulse access host, Pulse RT host, user add, host UID, host. Yeah, so this is the user, it's creating the user and the group. And what you'll see here is we're adding it to all these groups here, okay, and creating this host user. What these groups are, these are like root, wheel, the video group inside the container and on the host. So if I come across run groups, you'll see I'm in wheel operator video and my username. And if I look inside etc groups, group, etc group, what you'll see here is I'm in the wheel group, the operator group, the video group, which is 44. Okay. So the video group on FreeBSD is 44. Okay. And as I said, if you're paying attention, lsl dev Nvidia, right? Remember, we used the devfs.rules to change the permission so that the video group has access to the GPU. You can see here, read write the video group, right? So the video group on FreeBSD is 44. However, in the container, it's 39. Okay, so what we're doing is to allow access to the GPU by using the devfs rules, changing the permissions so the video group has access. You've got to set the video group to both the group on the FreeBSD side and in the container. So that's why we've got 39 and 49. Okay. Don't worry, it's going to get more complex. But don't worry, I mean, you think it's complex following along, that's nothing to how much work it was to actually figure this all out, okay? Let me just go, the cat probably wants more food. He's got biscuits downstairs, but it always forgets. No, Ollie. Okay. So this is how we create the groups, right? So this is creating the, let me just shoot. Been asleep all day and it just goes out at night because it's nice and cool. So what this is doing, the Docker file is actually creating the groups in the container that match the groups on the FreeBSD side so that we have access to the GPU. What we then have is setting up the permanent shell environment. So let me just zoom this in a bit. So this is the Wayland side. And what you'll see here is we are setting up the path. That's where these lighters get worse and worse. Okay. We're setting up the path. We're setting up the XDG runtime directory. And again, this host UID. Okay. Let's run user. doas lsl run user. And oh yeah, that's the DOL, my bad. That's inside the container. If I run print env on FreeBSD, what you'll see is the XDG runtime directory is var run XDG and my username. lsl var run XDG. Okay. I've got to run that with doas. What you'll see here is my username. And if I list the contents of that directory, what you will see is we got dbus, we got pulse, and most importantly, we have Wayland -0. And you can see that's a socket from the S here, and we got the XDG session. Okay. So what this actually does is this is defining variables inside the container for Wayland. And what we will actually be doing is we will be mounting the XDG runtime directory from FreeBSD into the container so that it has access to the Wayland socket for GUI applications and video players. So these are variables to set the XDG runtime directory, the Wayland display, the SDL video driver for ffplay, Qt and GDK. So this is for GUI applications. What we then have is user host user, which is for, this corresponds to the username on FreeBSD. We've got the work directory, so this is the default directory, and then we've got user root. Okay, so that's the Wayland version. Then what we have is the X11 version, and this is basically the same, apart from the packages that we actually install. So what you'll see here, the only difference here is instead of installing Wayland libraries, we're installing X11 libraries, and you don't need to have Xorg installed inside the container because it's on the host and we're using sockets. So it will use the X11 socket and display Windows on the FreeBSD host, which has Xorg installed. Okay, so if I now come back to this section, so as I said, that is the Docker images. Those are the base images that we are going to be building. So if you're on Wayland, you go into the Wayland directory. If you're on X11, you go into the X11 directory. Once you're in the correct directory, what you're going to do is build the base image. Okay. Now this is the secret source. Okay. You remember we had those args up here. We've got the arg, host UID, and host user. Okay, we've got doas, Podman build, network host, so that the image is going to use in networking on the host. And this is essential so that, as shows you, things like Ollama will be accessible on the host. Now, these are the two important things. OS Linux and Arch equals AMD64. And these are essential because we're pulling down Linux images. Okay, and we need to tell it, we're not on FreeBSD, we want to pull down the Linux image. Otherwise, without those, what it'll do is it'll throw an error saying, I forget what, but it will throw an error. And what you'll see down here is build arg host UID equals ID -u and host user equals user. If I run ID-u, see my user ID. If I run echo user, you'll see my username. Okay, so what this does is this bakes into the base image that we're going to be building your ID and username, and this is essential so that files created in the containers will have the same permissions as those on the FreeBSD host. So for example, when you're processing video files or you're downloading something with Firefox, they will be owned by your user and you won't have to chown them. Okay. Now this section you can ignore. This is how I build what's called the dummy-uvm.so. And the developer, whose name I can't pronounce, did a sterling job getting this working. And basically what this does is this tricks the container into thinking there is a file called, is it Nvidia UVM, and it stopped working after the Nvidia 535 driver, but a very nice chap on Reddit actually managed to fix this. Was it North Star Promise? Top bloke. So that it works with the latest drivers, and without this file the project wouldn't be possible to provide access to the GPU. So you can ignore this section. This is for me on how I actually build the dummy-uvm.so. So let me just go through there. So the first step is, as I said, you go through the initial setup, you build the base image, okay, and then what we have here is the different categories that I've set up: AI, scripts, browsers, Python, and we've got custom containers and instructions on pruning old images and upgrading containers. So in here we have AI and Ollama, And this is the instructions for setting up Ollama. So first of all, what you're going to want to do is actually create a ZFS dataset for Ollama. You can just create a regular directory if you like, but it's better to create a ZFS dataset. And again, what you need to do is change my username to your username in the examples below. So we're going to do doas zfs create zroot home username .ollama. And then we're going to change the permissions on that directory. So doas chown, that's capital R, username, home, your username .ollama. And what that does is that creates the Ollama directory. So this is the default directory that Ollama expects to find, and it will store the actual models. Okay, so when you're pulling down models, they will be stored in that directory. And as I said, you can just create a Ollama directory with mkdir-p tilde/.ollama. But as I said, you really should be using ZFS, and you're going to have to for Podman anyway. So this will allow you to create snapshots and roll things back and that kind of stuff. So what we need to do is change into the Ollama directory in the project. Okay. If we have a look in here, what you'll see is 4 files. We've got a .env file, a Docker file, a make file, and compose.yaml. So coming into containers, so this is the project root. We come into containers, AI. So I'll set this up so that rather than a big long list of things, we've got different categories. So AI, Ollama, show hidden files, you'll see the env file. So what we have is, as I said, we've got the env file. Let me show you that. So again, what we have is the same commenting setup. So you can see at a glance what the file is and what the project is. What we have down here is the XDG runtime directory, the XDG session type. Okay, these are variables that correspond to this. So if I run echo XDG session type, it shows Wayland. If you do that on X11, it will show X11. And this is required so that we have conditional logic in the compose.yaml file, which will check if you're running Wayland or X11, and actually it will link the Wayland or X11 socket into a new XDG runtime directory created in the container. And the reason for this is so that the temp and XDG, the X11 socket is actually in temp, whereas the Wayland socket is in the XDG runtime directory. And what we do is we actually create a new XDG runtime directory and temp directory in the container, and then symlink those files into those new locations. And all the XDG runtime directory and temp are actually mounted read-only. And the reason we do this is so that security, and also so that containers don't write to directories on the FreeBSD side. We then have the dbus session address. We got the host UID. We got the host username. And the way that this works is we actually have a make file. So what you do, just come across here. Close that. So you're in the Podman FreeBSD Cuda containers AI Ollama directory, and you'll see the make file. And what you do is you just run make. And what that does, if we have a look at the make file here, is you can see env file, all env, user equals ID UN, and what that ID UN, ID id-un. That gives us our username. id-u gives us our ID. What this is doing is this make file creates the .env file. And again, the .env files are ignored in the .ignore file and created with the make file. And the advantage of doing this is that you can edit the make files. The make files aren't tracked by Git, so that when you do a Git pull, they won't get overwritten or give you an error. So what we have here is a print statement that actually prints out the env file, okay? And then we have a clean, so you can run make clean and it removes stuff. Let me just close that. I'll do this with complex. I did warn you, but again, remember, trying to follow along is nothing to how many different challenges I had to overcome to get this to work and design the project. Okay, so the make file creates .env file. Okay, and you can see here we've got these things like host xdg runtime, host xdg session, host uid, host user. And what happens is once you run the make file, review these settings to make sure they're correct in the .env file. And those are actually used in the compose.yaml file. But what I'm going to do first of all is show you the Docker file for Ollama. So what you'll see here is, again, file, Docker file, project Ollama. And as I said, these are all set up with the same commenting style that I like, with a header at the top so that you don't accidentally, it's easy. I do it all the time, accidentally edit the wrong file. And what we have here is the heading, 2 spaces, a comment, a single line, the code, and then 2 lines, and then the next comment. And this is so that it's more readable and you can easily scan through the files and find what you're looking for. What you'll see here is from localhost base-image-latest, and that is the base image that we built. Okay, doas Podman images. What you'll see here is we got okay, this one here, docker.io library Rocky Linux 9.3. This is the Rocky Linux image that we pull down. Okay, and then what we do is we're building the localhost base image. Okay, whether it's Wayland or X11, and then from this base image, which is built from the Rocky Linux 9.3 image and is built for Wayland or X11, we are actually installing separate packages. And what you'll see here is arg host user and arg Ollama version. So let's have a look at the build the Ollama code. And what you'll see here is doas podman build network host OS Linux build args host user equals user. So that's your username. And then we've got the Ollama version. Okay, at the current time of recording is 24. So what you do is you don't edit the files in the project. You copy this code, and what you do is you just increment the version number to the current version of Ollama. Right. So we've got a way to specify the version of Ollama that you want to install. And what you'll see here is it's building an image called localhost Ollama. Okay, localhost Ollama latest. So the full name is actually localhost. The full name of these images will be localhost /Ollama latest. Right. So you build the image, right? And what you'll see here is we've got the LD library path. And what this is you've got user lib64, user lib64 Nvidia host. Okay. User lib what this is doing is this is actually setting the library path, which is going to be defined in the compose.yaml file. So what we're actually going to be doing is the container has a library path of userlib64, okay? And what we're doing is we're mounting the Linuxulator libraries from FreeBSD into the container, but what we don't want to do is overwrite the existing libraries in the container. So what we are doing is we are mounting the Linuxulator libraries into userlib64 Nvidia-host, and we are appending that path to the LD library path. So what this means is applications look for libraries in userlib64, which is the container libraries, and then also look in userlib64 Nvidia-host, which is the mounted Linuxulator libraries from FreeBSD. Yes, I know what you're thinking is my head's exploding. It gets worse. But as I said, just bear in mind, however difficult you're finding this to follow along and making your brain fry, how many different things that I had to go through to get this to actually work. Okay. This is all built on my knowledge of building Rocky Linux jails for things like DaVinci Resolve. So this is AI slot. This is all my own work. This is my knowledge across multiple subjects of devfs.rules, containers, Podman, groups, permissions, sockets, all that kind of stuff comes into play, right? So what we then next do is we are installing ZSTD, and this is required by tar to untar the Ollama tar.zst file. So what you'll see down here in this Ollama install section is we are pulling down the release, and you'll see this Ollama version, okay? That corresponds to this section here. Ollama version corresponds to whatever in here, the version number, right? So we're pulling down the Ollama tar.zst and we're saving it to the temp directory in the container to tar.zst. What we then do is we're actually running tar with the ZSTD program, because it's a ZST extension, and extracting it to user, and we need to change mod the permissions on userlib Ollama to 755 and the user bin Ollama binary, and then finally clean up by removing the tar.zst file. And what this does down at the bottom is this drops down to your matching user context, which is the user is your host user. Again, that's the host user on FreeBSD. Okay. Right, compose.yaml. This is where the magic happens. Okay, I know I've been going on for 2 hours, but you're thinking, oh mate, this takes time, but I need to explain everything so that you understand how all this works, okay, in depth. And the reason for that is so that you've got an understanding of how the project works and how all the different components fit together. It's like Lego. Okay. Best way to describe this is when you're a kid, you get a box of Lego and have a picture on the front. Okay. That's what you're supposed to build. In this analogy, Lego are code blocks, just like you pipe things, chain different commands together. Basically what we're doing is we're fitting bits of Lego into different, permutations to build something that's not on the box. And to do that requires understanding every piece of Lego, its structure, its form, and how it can actually fit together with other pieces that we have got at our hands. This is what I used to do as a kid. First of all, I'd sit there and I'd examine every piece, try each piece and see how it connects together. But eventually what I would do is, rather than by knowing all the pieces, okay, so by knowing all the bits of code, you know, Lego blocks of code, I would be able in my head to be able to manually put the pieces together and see how they would fit together without physically doing it. And this is the same process that I'm applying to how the code works. So we've got all these bits of code and I'm mentally juggling them around to see how they all fit together to build something that's not on the box, okay? Which in this case is, we've got FreeBSD without Cuda, and I figured out a way by arranging the blocks in a particular way to get Cuda to work, right? So again, file compose.yaml project service configuration. So this is the name GPU app. We've got build context. So this is building with the current file. We've got networking host. Again, we've got the args. So host user equals host user. So again, this is pulling the host user. Okay, the host user, got the host user down here, the host UID in the .env file that's created from the make file. Okay. So what this is doing, this is how we set up the Podman container to run as the exact same user on FreeBSD, is by using the env file, which contains your user and your ID, and using it within the compose.yaml file, right? Makes sense? Then we've got the image name. So this is the name of the image that we're creating. As I said, localhost Ollama latest. Set the platform, the container name, the user. So this is running the container as our user. Yeah. So it's, as I said, this is the exact same user on FreeBSD as in the container as on FreeBSD, so that all permissions and everything work. You've got OS Linux networking mode host, so it uses the host networking. And as you'll see, everything is commented so that you will understand it as you go through. We've got STD in and TTY, and that keeps the that's for standard in and creating a TTY. We have stop signal sig kill, and this is so that when you run, you exit the container, when you run doas podman compose down, the container exits cleanly, right? Next, we got the volumes, mounts, hosts, binding, and jail socket. So volumes, okay. Host library and Nvidia bindings. I need to get another thing on the go. Right, so what you'll see here is Linuxulator libraries, compact Linux user lib64, mounted to user lib64 Nvidia host RO. RO means read only. So what this is doing is this is mounting the compact. I'll list this here. This is the secret source, okay? This is the stuff no one's thought of. And this is the sort of the breakthrough, is instead of installing a, as I did in a jail for DaVinci Resolve, that required manually installing the exact same driver as on the FreeBSD host. Okay. What this does, if I show you here, all right. So that is the directory, and if I do asterisk Nvidia asterisk, what you'll see here is we've got compact Linux user 64 and all these Linux libraries, okay? Yeah. So there's no way you're going to mount all of these files individually, because these files, you have files that you've got symlinks that link to files, and okay. So what we are doing is we are mounting the entire compact Linux user lib64 directory from the FreeBSD Linuxulator into the container a userlib64 Nvidia host as read-only. And I said the userlib64 Nvidia host is appended to the LD library path. Okay, remember that section. Then what we have is the Nvidia SMI. So compact Linux user bin Nvidia SMI is mounted read-only to the same location in the container. Then we have the dummy-uvm.so, and this is why you need to keep the project's structure the same. So I said the dummy-uvm file is what tricks the container into thinking there is a Nvidia UVM device. Okay. Now, instead of installing the dummy-uvm.so file in every project, what we're doing is we're linking to it several levels up. You remember base build, dummy-uvm, dummy-uvm.so, and that is mounted from the repository into userlib64 dummy-uvm.so as read-only. Okay, so that's the trick. All right. Then what we're doing is we're actually mounting the Linuxulator directories. What you'll see here is compact Linux proc, that's mounted to proc. Compact Linux SYS is mounted to SYS, and FD is mounted to devfd. Okay. Then finally, what we have down here is tempfs Rocky SHM mounted to devshm, and that is at the end of the file, and that is a tempfs file storage that is required in the container. Okay. Again, bear in mind, as I said, maybe having trouble following along, but each of these things had to be worked out, and is a component in getting all this to work together. So, you know, you can see how much work goes into this stuff. Not easy. If it was easy, someone else would have done it already. Yeah. So again, bear in mind, what we're doing is we're changing the entire operating system. We're sticking it to the man Nvidia who doesn't want to give us Cuda. And we're getting Cuda working regardless. And so, yeah, we're getting something working regardless of not having native access to it on FreeBSD. And also sticking it to a multi-billion-pound company, which is nice. So what we've got here is temp directory for PulseAudio socket. So what we're doing is the item on the left of the colon is the FreeBSD host, and on the right is the container. So what we're doing is we are mounting the temp directory from FreeBSD as read-only to temp in the container, and that will contain the PulseAudio socket. And if you're using X11, it will contain the X11 Unix X0 socket for Xorg. Okay. Next, XDG runtime for the Wayland socket. So we're actually mounting the XDG runtime directory. Okay, that's set in the host XDG runtime directory is set in the env file, and that corresponds to the XDG runtime directory. So with var run user your username. That not only contains the Wayland socket, but also contains dbus directories and PulseAudio. And what we're doing is we're mounting it to run user host UID, and that is going to be 1001 if you are the first user on the FreeBSD system. As I said, that is automatically set in the Pulse in the .env file that's created with the make file that automatically detects your settings. So nice touch. What we then have is the XDG runtime directory in the container. So what we got this thing here, Rocky writable run user host UID writable read-write. What we're actually doing is we're mounting temp and the XDG runtime directory as read-only. Okay, and what we're going to be doing is creating a new temp directory and a new XDG runtime directory in the container, and then symlinking sockets and dbus and pulse into the new directories. What we then have here is app mounts. So what you'll see here is home host user. So this is your username .ollama. So this is going to be home your username .ollama, which is the ZFS dataset or directory you created for the Ollama models. And it is vitally important that you create this directory before you actually set up Ollama, because otherwise the permissions, if you set it up beforehand, the permissions will remain owned by your user. If you don't, the Podman container will actually create the directory and it will be owned by root, and you'll have issues and you'll have to change the permissions. So what this is doing, it is mounting the Ollama directory to Ollama in the container. So it's not actually, it's making this path accessible inside the container at the same location, so that Ollama running in the container sees .ollama in the home file, but it's actually on the FreeBSD side mounted. Okay, entry point and shell initialization. What we're doing is we're actually creating the temp directory, home user temp. We're creating a cache directory, a local share. What we're then doing is we're creating run user, your host UID, so that's going to be 1001 or whatever your thing is, dash writable. So this is going to be the writable XDG runtime in the container. Then what we have here, we're symlinking the display socket from the read-only path into the writable one. So what we have here is Wayland and X11 and then a case statement. Okay, so the host XDG session type is set in the env file, and that corresponds to your session type, whether it's Wayland or X11. So the case statement will run a function. So if host XDG session type is set to Wayland, it runs the Wayland section, the Wayland function. If it's X11, it runs the X11 section, and these are set in the env file. We've got the Wayland function here. And what this does is this symlinks the Wayland socket from the read-only XDG runtime into the writable XDG runtime directory. And if you're on X11, it will create a symlink from the temp x11xo directory. It will create the temp x11 Unix and then symlink it. So that's how we mount the sockets. Then what we have to do is we have the XDG runtime directory mounted, and in that directory there is a pulse directory. And if I can, I got it. Okay. There was lsl bar run xdg. Okay, so this is the XDG runtime directory on FreeBSD, and as you can see here, we've got dbus, got pulse, got Wayland. So what this does is this symlinks the pulse directory from the read-only mounted XDG runtime directory into the writable XDG runtime directory that we created, creating the same directory structure. We then do the same thing for dbus. We symlink the XDG session handle if it's present. We then need to fix the ownership of the writable directory and the temp directory. So we'll have a home temp directory. We change the permissions. And this is where we append environmental parameters into the bashrc file. Let me go through this and get this bloody lighter set up. Okay. So first of all, what we have is LD library path. And remember I said the LD library path in the container is userlib64. And what we are doing is we are mounting, we've got the userlib64 Nvidia host, and that corresponds to the Linuxulator libraries. And what this does is this appends the Linuxulator libraries from FreeBSD to the system, to the LD library path in the container. So that it first looks here, and then it looks in here for all the Nvidia stuff. We then preload the dummy-uvm.so. Again, that's the file that tricks the container into thinking there's an Nvidia UVM device. We export the bus address, which is again the host dbus address session bus address. That corresponds to the bus address in the env file that's created with the make file that uses environmental variables to get your settings. We then set the temp directory to temp. So what we're doing is we're setting temp directory to home, username temp. And again, that is so that we have a writable temp directory in the container, as opposed to trying to write to the temp directory on the FreeBSD host, which we don't want to do. And then finally, what we're doing is we're exporting the XDG runtime directories, XDG runtime, XDG config home. So this is the XDG runtime directory, again, the writable one we created. Then we have the XDG config.home. So again, you'll know .config, that is where's where the stuff stored. Okay, we've got the cache directory .cache, and data home is local share. All those are redirected into the bash rc file, which is the shell that is used in the container. Finally, what we do is we're actually executing bin bash, so that when you enter the container, you are put in a bash shell inside the container that will be in the home directory of the user that corresponds to the user on FreeBSD. We then have the volumes down here. So what we have for Ollama, we have a tempfs file with 4 gig size, and that's required for running the Ollama. And then we have a writable runtime directory here. Okay, so that's Ollama. All right, that's building a container. What you do is you run the make file. Okay, change into the Ollama directory, you run the make file, that creates the env file that you then review to make sure all the settings are correct. You then build the Ollama container, changing the version number to the latest version. We then start the container with doas podman compose up-d. Okay, yeah, so you're in the Ollama directory, doas podman compose up-e. You then enter the directory with doas podman exec-it-u user. That's your username on FreeBSD, which corresponds to the user in the container. Ollama is the name of the container that we're entering, and we're going into a bin bash shell. And remember, for Ollama serve, if you're using a newer graphics card, you can just run Ollama serve. But because I'm running what's called a Turing Nvidia GPU, which is a GeForce GTX 1650, you need to use the following code to use Cuda v12, which is Ollama LLM version equals Cuda_v12 Ollama serve. Right. When you're done, you can just exit the container and run doas podman compose down. Right. Next is the script. So again, I said, I know it takes a long time to go through this. So I could just have gone, okay, here's the project, get on with it. But I'm going through all the steps so that you can actually follow along easily. And it kind of makes sense. So we go into the scripts. ffmpeg. Okay. So again, come to the base level project. Got the README base builds containers. Containers is where the containers are. You come into scripts, ffmpeg. What you'll see here, got the env file, the docker file, the make file, the bin directory, compose.yaml, and .files. All right. So you change into the directory, you run the make file. Okay. Let's have a look at the make file. So again, shows you the project name, phony. This is how you can run make clean, and it removes the directories. And what we have down here is various variables. So bin directory, .files, config directory. So you can see what .files, that corresponds to this .files directory. And this is what's going to be created by makefile. And this is for persistent storage. We've got config, pulse. So we've got .files. Then we've got .files directory config, pulse default PA, Dino. So this is for Dino, required by YTDLP. We've got the env file. We got the URL, which is my ffmpeg Rust scripts, archive scripts. And what we have here is the default build target. So env install bin. You create the bin directory. So the makefile will create a bin directory. It creates a .files directory. It creates a config directory inside the .files directory. And inside the config file, it creates a config directory. It creates the pulse directory. And inside the pulse directory, it creates the default PA and echoes default server equals emp pulse audio socket into the default PA file. And that is what works with the pulse audio socket that is mounted from the FreeBSD host into the container. Following along? Okay. And my scripts use Dino and YTDLP, and one of these scripts actually allows you to trim online videos. So trim remote clip, I think it's called, from memory, or trim clip remote, trim clip, trim remote clip, yeah. And what this basically does is this allows you to download a section of a video. So rather than downloading an entire video, if you say just want a clip from 5 minutes to 5 minutes 30, this script will allow you to do that by specifying a start time and an end time. That's why we've got YTDLP and Dino installed. And what we have here in the make file again is this user ID and user ID -un and ID u. So this is your username and your ID. And what we're doing is here, we're seeing if you've got a videos lowercase or video lowercase directory on the FreeBSD side. And what it will do is it will then use that directory as a mount point to mount that directory into the container. Okay. We got the settings for the env file, so the STG runtime directory session type. So this is the session type. So this is how we work out whether you're running Wayland or X11. And obviously you've built the base image as Wayland or X11. We've got the dbus address. We got the host UID user. We got the mount point. We've got the bin directory that's created. And what we're doing here is we're downloading the scripts, and we've got the clean. Okay, so what the make file does is it creates downloads the scripts into the bin directory and creates the .files directory. If I go into the .files directory, you'll see we've got pulse, default PA, right? So you've got persistent storage. Okay, so you've got mounted directories from the FreeBSD side to mount things like scripts into the container, because when you pull down a container, it deletes everything. So you've got mount directory to mount the scripts, and we have a .files directory for persistent storage for files used by the application in the container. Then we've got the compose.yaml file. Okay, so as I said, you run the make file. Make sure if you want to use ffplay in the container, you need to have the view control, volume control, PulseAudio application open and kept open on FreeBSD so that the socket remains open. You don't need to do that with graphical applications because the graphical application will keep the socket open, whereas command line applications won't. What we then do is, after running the make file to create the directories, the env, the bin directory, the .files, we then build the ffmpeg container, doas podman build, network host, OS Linux, build args, host user equals user. So it's building it with your user. And this is the tag localhost ffmpeg scripts. Okay. You then start the container, doas podman compose up-d. What you want to do is, after starting it, you don't want to enter it straight away. You need to view the logs and wait for the install to finish, because what it's going to do is it's going to pull down the latest version of YTDLP and Dino. So that's another advantage of this setup, is that you will have the latest version of YTDLP and Dino available inside a container, and because you've got the video directory mounted on the FreeBSD side, you can enter the video directory in the container and then download stuff, and it will show up on the video directory on the FreeBSD host. Right? So you view the logs. Once the logs have shown you that the install is finished, it will you then Control-C to exit the logs. You then enter the container by running doas podman exec it, which is for an interactive terminal -u, your user ffmpeg scripts, which is the name of the container, bin bash, that puts you at the bash shell. You can then change into the video directory inside the container, and you can then use the ffmpeg scripts to process video files, as I showed you, trimming the agent 327 video. Okay, and if I just come across to GitHub, I'll just give you a quick overview of the comes to my profile. All right, what you'll see here is ffmpeg Rust scripts, and these are a selection of about 35 or so Rust scripts that I wrote that, as I said, on Linux have nvenc hardware accelerated coding. So you have hardware accelerated encoding in the Podman container using these scripts, and they're divided into several categories: trimming and clipping, visualization, chapters, metadata, files, filters and overlay, color grading, conversion, scene detection. So what I'll do is give you a brief overview. You've got trim clip, trimming clips, trim remote clip, trim short to create shorts for TikTok and YouTube. Additionally, you can specify an x-axis to define whether the short is created from the left, the center, or the right. We've got combined clips for combining clips. We've got waveform. We've got scopes, which are visualization that you would get in a video editor, showing you the color range, the histogram, the RGB. We've got an EBU meter for measuring audio levels. You can create a contact sheet. You can add chapters to a video using a CSV file. You can extract chapters. You can add subtitles, all without re-encoding. You've got filters and overlay clips, like adding a B-roll, picture-in-picture, creates a little picture-in-picture. Fade clips, to fade a clip, you've got X-fade clips, which allows you to combine multiple video clips with different fades in between them. You've got pan scan and zoom pan, which are like panning and scanning over images like Ken Burns. You've got color grading, so you can create LUTs, which are lookup tables, and what it does is it creates a an image that you can edit in GIMP and adjust the color and saturation and stuff of the image, and you can then apply that image back to the video. So this is how you can actually color grade footage using GIMP. We've got conversion extras, audio silence for adding silent audio to a video. Blur fill will blur the, if you've got a 4:3 video, it will blur the sides instead of having the black letterbox. Concatenating videos to join videos together. Delogoing to remove logos. Extract a frame. Hstack to stack videos. Image to video turns a image into a video. Doesn't animate, it just turns it into a video file. Normalizing audio. Sexagesimal time for working out timestamps. Vid to GIF for creating GIFs from videos. WebP for creating WebP from videos. And then we got scene detection, automatic scene detection that will chop a video up into different scenes based on changes on the scenes with additional with timestamps. And you can also create images at the scene changes as well. So that's my ffmpeg scripts. Okay, and another note is if you want to view the YTDLP help in the container, you need to pipe it into less, because otherwise you get issues with the TTY in the container. Yeah, it'll crash the container if you just, because it spits the stuff out so quickly from the YTTLP-H option. The help sort of fills up several screens, so you pipe it into less. Okay. And then you can exit the container and bring it down. And what we have in here is the compose.yaml for the project. And I know I'm going on a bit, but you know, I've got to cover all this stuff in depth so that you have a complete and full understanding of how all the pieces work, so that you actually understand the code. Yeah. Don't understand something, then you know, there's nothing more frustrating than you know, people creating a project and not explaining stuff. So that's why I'm going into as much depth as possible so that you understand it. Again, the compose.yaml is similar to the other one I showed you. We got the image name here. Okay. ffmpeg scripts latest, host UID, sysctl. Again, we're mounting the Linuxulator libraries, Nvidia SMO, dummy-uvm.so, mounting the gel socket, the compact Linux directories from FreeBSD to inside the container. Tempfs, we're mounting temp to temp. We got the XDG runtime directory, got the writable directory for the XDG runtime directory. And what we've got here is the automated persistent application config workspace. And what this is the, if I come across, what you'll see is the dot files here, big and Dino. So this is Dino, C, Pulse. So we have persistent directories that are stored on FreeBSD outside the container, so that when you stop the container, it doesn't destroy the config files. Yeah, makes sense. And we've got the app mount, so we're mounting the bin directory. The host bin is defined in the, these are defined in the env file. So the host bin is mounted to home host user host bin, so that's ~bin. And the mount directory, the host mount, is the video directory from the env file created with the make file that's mounted from the FreeBSD host to inside the Linux container. And again, because we've got the permissions exactly the same inside the container as on the FreeBSD host, any files you create inside the container are owned by the user on FreeBSD. And so you've got a way to not even transfer, it's just mounted from FreeBSD into the container. So you've got file access. All right. The entry point, we create the temp, the directories. Again, we got the check for the, whether it's Wayland or X11 using the case statement from the env using the XDG session type, which is either Wayland or X11. We then link the PulseAudio, the dbus, the XDG session, change the permissions. This is where we download YTDLP, so this checks if YTDLP exists, and this will be saved into the bin directory that is created. So you got YTDLP downloaded, we've got Dino downloaded, okay, and what you'll see here, temp directory. So Dino actually uses the temp directory, which is home temp, to download in the container as opposed to downloading into the temp directory on FreeBSD, okay, which is mounted read only, right? So a lot of thought goes into this stuff, you know. Then we're exporting the LD library path, as I said. We're appending the Nvidia host. We're preloading the dummy-uvm.so, setting the base address. We're setting the temp directory to temp, and we're exporting the XDG runtimes, and we're adding Dino bin to the shell path. Okay, so we're setting the shell path inside the bash RC inside the container so that it has YTDLP combined Dino, and we execute bin bash, and then we've got the volumes down here. So that is ffmpeg. All right, so that's ffmpeg, and I know this is a bit of a marathon one, going past 2 hours 37 minutes. So just bear with me, because it's important that you go through all this, because as I said, it's possible there's things that I've overlooked in the documentation, which really is the least fun part of creating a project. But it's got to be done, because just like audio is half the picture, documentation is half the project. So Firefox. So this is setting up Firefox. So let's come back out here. So browsers, Firefox. So we're in the FreeBSD Cuda containers section, and you can see we've got browsers. And again, I've organized this into categories so that it's easier to actually go through them rather than just having a big long list of stuff. Just makes it cleaner. And so, you know, if you want to, you know, I can create stuff for different browsers if needed. So browsers, Firefox, and what you'll see here is we've got .env, dockerfile, makefile, bin, compose.yaml, and dot files. All right. So we've got the env, docker, makefile, bin, compose, dot files. So the first step is you need to change into the Firefox directory. cd Podman Cuda, FreeBSD Cuda containers, browsers, Firefox. Right. Then you run the makefile. And this will create the env file, which will set your username, ID, and the mounted downloads directory. So, I mean, the other thing about this is does help me pick up any typos or stuff in the documentation as I go through it, because you know, it's easy to miss things as you're going through writing it. So what you do, oh, you bastard, come on. Right. So in the Firefox directory, you just run make, okay? And what that will do is that will create the env file. It'll create the bin file with this wrapper Podman script, and it will create this dot files directory. And what you'll see here is we've got cache, config, and Mozilla. Okay, so these are persistent directories which allow Firefox to retain its settings, browser history, bookmarks, all that stuff on the FreeBSD side, so that when you stop the container, the settings are retained. So when you open up Firefox again, using the desktop entry, you'll be back off where you left off. So we got cache, config, okay, dconf, GTK, pulse. We've got Mozilla, and what you'll see here is we've got extensions and Firefox. And what you're going to need to do is find the default directory for the profile, okay? So you run the make file and it creates the env file. So let's go through the env file. And you need to review this after running make just to make sure everything's good. And what you see here is we've got the XDG runtime, session type, so that's going to be Wayland. I know it says XDG session type, but that's a variable that is then used in the compose.yaml file. We've got your host UID, your host username, the mount. So what the make file does is it scans to check if you've got a uppercase or lowercase downloads directory, and then uses that as the mount point to mount that directory from the FreeBSD side into the container. Right. And then what we have is the host bin directory. And what this does is this mounts the bin directory that is going to be created with the wrapper Podman script that is used with the wrapper-freebsd script that's used with the Firefox desktop entry. Okay. So you run the make file and you review that, and you can see we've got the bin directory here. So you build the Firefox container just like we did with the other ones. You tag localhost Firefox. You then start the container. You can then enter the container. But so after you've actually built the container, what you can do is you can actually just run Firefox Podman. Give it a second. And it should open up, but it's, it's a demo. So, there we go. Right. So it's not normally that slow. It's just because, I'm recording at the same time. So what you need to do, okay, is two things. We've got to enable Widevine support, and we have to enable hardware accelerated video playback. So what you do is come into Widevine. You can either use the hamburger menu, or you can just go to about settings. So hamburger menu settings, yeah, or you can just go to about settings. And what this does is this takes you to the general tab, and what you need to do is scroll down to this section, digital rights management DRM content, and just click this box. Then you're going to want to leave the browser open for a minute or two, and what that will do is that will download the Widevine binary doodah for playing back DRM content. Okay. You then want to open about profiles. Right. And what this will do is this will show you the name of the default profile. So you can see here, home username.mozilla firefox.default-default, okay? Make a note of that. And what we're going to do is we're going to close the browser. If you come into you have a look here, we're in the Firefox directory, you'll see .files. Yeah. Inside that .files directory, you go into Mozilla Firefox, and what you'll see here is the default directory, okay? You go into that, and what you'll see here is we've got the GMP, we've got the Widevine, okay, the manifest. And what we're going to do is you'll see this user.js file that I've copied in here. So what we need to do, this user.js file, okay, This is what enables hardware accelerated video. And the reason why I want to use a JS file as opposed to doing it in about config is so that the settings are retained. Because I said that they'll be applied because they're in the persistent storage container, they will be retained as opposed to using about config. So what we need to do is copy the user.js file into the container. So cp podman FreeBSD user base build assets applications Firefox user.js, and we're going to be copying that into Podman FreeBSD Cuda, containers, browsers, Firefox, dot files, Mozilla, Firefox, that directory. Okay. Check your profile before copying the file. Okay. So if I come back out of here, base build, assets, applications, Firefox, user.js. So you copy the user.js file into the profile, right? Make sure you've closed Firefox. Then if you just reopen, you may need to stop the, bring the container down and then run the desktop entry again, and it will reopen Firefox, and then it will have hardware accelerated encoding, playback rather. Okay. Right. So you can then exit the container of Podman Compose down, and here is the FreeBSD podman.desktop entry to launch Firefox in the container. And what you want to do is copy that into local share applications on FreeBSD using this command. And if I come across and show you that, assets, applications, Firefox, Firefox desktop, what you'll see here is we've got the wrapper-freebsd-j, Firefox-a, Firefox-c, pose.yaml, and then the path to the env file. And what we'll do is we'll take a look at the wrapper-freebsd script. Okay. Again, file, project, script usage, get ops. So what this does is these are get ops options. So these are options passed to the script that correspond to the options in the Firefox podman.desktop entry. Okay, -j, -a, -c, -e. So -j is jail. I'm thinking jail? This is a Podman container. But as I said, Podman containers are jails. You run doas jls when a Podman container is up, it will show you that it is actually a jail. So doas podman pose-up-d doas jls. We've got the jail ID, we've got the host name, and then we've got the path. Right. Doas podman compose-down. Right. So Podman containers are jail, so that's how we can use the devfs.rules with Podman containers. So we've got -j for the jail, which is going to be used to target the ID. We've got the app, that's going to be the app that is actually launched inside the container, so that we have a wrapper-freebsd and the wrapper-podman scripts that are used with desktop applications, and they're flexible as opposed to specifying, Firefox or whatever. Means we can create desktop entries that pass in different variables to launch different applications in different containers. What we then have is -C compose, -E for EMV, and -P for audio, P for PulseAudio. And what this does is this allows, rather than doing something like having a script that has to enter a directory so that it's in the same directory as the compose.yaml file and the .env file, we can actually pass in the path to those files using those options. Okay, and what we have here is stuff to check if PulseAudio wants to be started or not. Then what we have to do is actually, we check if the container is actually running. If not, we start it. Then what we have to do is we have to actually get the, we check the state, and then what we've got to do is find the Podman ID. So as I showed you, when we ran JLS, just gives us jail ID. It doesn't give us any other indication. It doesn't say Firefox. Yeah, and these numbers are going to increment each time you start and stop a container. So we need a way to actually figure out what the Podman container's jail ID is. And the way that we can do that is actually, you see it's got this path here and this string of numbers. And this string of numbers actually corresponds to the Podman container. So we have to figure out a way to actually get the Podman container ID. And then what we do, once we've done that, so we do that by getting the JID 12, and that we do some madness to actually check that against the Podman container's name, and that makes sure we're launching the right container. And then this is another thing, the secret source. Okay, JExec, right? Now you might be thinking, you can launch Podman containers a variety of ways using doas run, Podman run, but that bypasses env files and compose files, so we can't use that. You also have doas Podman exec, right? Can't use that. And the reason why is because it's running as root. And if you try and do that, what it's going to do is it's going to launch the application inside the container with root permissions. You want to run applications as root. It also changes all the permissions inside the container to be owned by root, that then breaks the access to the GPU and stuff. So this is where I had to have another gallon of tea or so, and a couple of packets of biscuits to figure this out. And again, this is why I'm mentioning that Podman containers are jails, right? That's important because we can run jail commands on Podman containers. So we've got doas jexec-user. This is our user on FreeBSD. The jail ID, bin bash ilc. So what this does is this sources the bash RC inside the container that picks up all the environmental variables, the XDG runtime directories, the temp, all that kind of stuff. And it runs home bin wrapper, which the wrapper Podman script. Oh, this was complex, I wasn't lying, but again, it's a hell of a lot longer to figure out than to explain. So what you see is the bin directory here, okay? This bin directory is mounted from the FreeBSD side into the container, and it has a script called wrapper-podman. Right? So the desktop entry works with the wrapper-freebsd script, then works with the wrapper-podman script inside the container that launches the applications. So what we're doing here is we're running doas jexec. We're running the bin wrapper-podman script -a app, okay? Local share applications, Firefox Podman, and what you'll see here is those options correspond to the desktop entry, and you'll see here jail Firefox, application Firefox. Okay, That's then passed into this script, right? So app-a corresponds to -a there. So that's the application we want to launch, which is Firefox. This script then calls the wrapper-Podman script. I'm thinking, why does it need to be so complicated to launch an application? Can't you just run doas podman exec Firefox? No, you can't, because I said it will be owned by root and it'll break everything. So this is why this is a technique I'm borrowing from my previous work in setting up DaVinci Resolve inside a jail. To launch things inside a jail from FreeBSD, you actually launch them from inside the container by running a script inside the container that is called from a script outside the container, called by a desktop entry. Right. And I wasn't kidding when I said there was many parts to this to actually get it to work, right? So we've got the wrapper-podman script usage. What we have here is the get ops. So we've got the app, the help. So the app passed in from this script here, -a app, which then passed in from here, which is Firefox. So Firefox gets passed into this, that then gets passed into this, stored in the app variable here. And then what we have is Firefox, and this is a wildcard that allows things like new window, private windows, or URL to be clicked, and send the output to dev null, and then exit cleanly. All right. Okay, so that's Firefox. So Python, WhisperX. So should give you a good grounding and knowledge on how to build your own containers, right? That's the point. Is the reason I'm going into this in a lot of depth, maybe more depth than you'd like, is so that you have a full understanding of all the components that are needed to pull this off. As I said, this is a method I invented based on previous work that I've done with jails and running applications and all that kind of stuff. And as I said, it's only through having a deep knowledge across multiple subjects and how things work, Linuxulator, devfs.rules, groups, sockets, Nvidia graphics cards, permissions, all that kind of stuff. Only by understanding stuff and reading the manual that you can actually think things through logically to actually get this to work. All right. So that's the wrapper-podman script. So now what we're going to do is come into, we've done the script, we've done Ollama, we've done browsers, and now we're going to look at Python. So what you'll see here in the WhisperX directories, we've got the env file, the docker file, the make file, the compose.yaml file, and the dot files. And the dot files contains the cache. And what this is the persistence settings for the WhisperX models. Okay, so we got hugging face, and we've got a token to go through. We've got pip, we've got torch, we've got the virtual environment here. Okay, so what we have to do is we're actually creating a virtual environment to install WhisperX and pull down all the models, and my light has gone. Oh, there we go. Last little bit of gas. So the reason why you want to learn about the WhisperX and Python side of things is because this allows us to run any Python application that uses Cuda on FreeBSD, which wasn't possible before. So that means things like WhisperX can also run text-to-speech, things like Kokoro. to generate audio from text. Also means things like stable diffusion, comfy UI for creating images, which is a really nice application. Also means that if you have enough VRAM in your graphics card, you will be able to use comfy UI to generate videos. So, a bit more water. And we've hit the 3-hour mark. It's probably a new long time record for me. And this file will be, because I'm recording with nvenc, this is going to be like 10 or 12 or 15 gig for me to upload. So I'll probably have to set this to upload overnight, because otherwise it's going to take all day to upload. But anyway, right. Change into the WhisperX directory. Right. Again, what's the first thing you do? You run the make file. This creates the persistent storage directories and the env file, which set your username ID in the mounted videos directory. That's incorrect. We do. Yeah, we are mounting the videos directory for WhisperX, and you need to review the env file to make sure everything's correct. So basically, you just run make. That builds the make file. So the make file. So let's go through the make file. Again, the file, the project, pony. So this is used when you run make clean to actually remove the stuff. We then have the persistent storage. So we create the .files directory. Inside that, there's the cache file, the Hugging Face file, which is used for, you have to create a token on Hugging Face. So Hugging Face. So what you need to do is to have access to the WhisperX models, you actually have to sign up, and you've got to create a token file, and you also have to accept the speaker diarization. You've got to fill out a tiny little form. It's totally free, but you have to create the token and accept the license to be able to download the models. Okay. So we've got the cache directory, which the token, the virtual environment, and the env file. Default target, we create the directories. We check the video directories, which are going to be mounted from the FreeBSD side into the container. We create the env file, which sets the XGG runtime, checks the session type, Wayland or X11, the dbus, host UID or user, the mount directory. Okay, and then we've got the make clean, and what that does is that creates the env file. And again, this is not tracked by Git, so you can edit this and still do a Git pull, and it won't be overwritten or give you errors. That's the way. That's the reason why I designed it this way. I had to put a lot of thought into actually how you could actually have, rather than distributing env files that you then change and then have to run some mad Git commands to ignore. This is the easiest way, most user-friendly way for you to do stuff. Just run make bang, creates all the directories for the persistent storage, the env file that you would then review. Okay, so you just need to check the UID, the host user, and the mount point are correct. Right. What you then need to do is add your Hugging Face token to the file. So you sign up for the Hugging Face and create an access token. You then need to go to the speaker diarization URL. So what you need to do is speaker diarization is what creates speaker 1, speaker 2 when you're transcribing audio with more than one person, and basically you sign up and you log in, and you have to sign up, review the conditions, and just put in some little details and click accept. Once you've done that, you'll be able to download the models. What you have to do is inside the .files cache Hugging Face token directory, you can see here .files hash Hugging Face token. You edit this file and you put in your token from Hugging Face, right? You can then build the container like so. It can be called localhost WhisperX. You can then start the container, but what you then need to do is actually view the logs and wait for the install to finish, because the this is going to pull down some stuff. So once Control C to exit logs. This helps me going through this to actually improve the documentation for you, and otherwise you'd be thinking, how do I exit the logs, you know? You then enter the container after it's started up and the logs showed you everything's downloaded. We then run the Python check, okay, with this code, and then what it'll do is output something like this: Cuda variable equals true, and it'll list your graphics card. Once that's done, you're good to go. Now, then what we have is the models download. So what you're going to want to do is change directory into the video directory. And what you're going to want to do is have a audio file or a video file, in this example called input.wav. And what we're going to be doing is we're going to be downloading the small model. Okay, so we're going to be running this code: WhisperX input.wav device Cuda model small diarise. And what this is going to do is this will actually download the model from Hugging Face, which will then actually be stored yeah, there you go. Okay, so you can see here WhisperX.file cache Hugging Face hub, and you'll see the models, got medium and small models, and the speaker diarization. So again, this is why we have the persistent container, because otherwise what would happen is if we didn't have the persistent container, every time you stopped the container and restarted it, we'd have to download the models every time, which is crap. So what this does is this stores the models outside the container on the FreeBSD side. Okay, so that will download the model. Once it's finished downloading, it will transcribe the audio into subtitled files. If you want to download the medium model, same thing. I really hate writing documentation, but you've got to kind of make this stuff idiot proof, because otherwise, you know, if I didn't document every single step, you'd get stuck, and then I'd be like inundated with comments. So we do the same thing. We basically run this code, and this will download the medium model. And as I said, if you've got a bigger graphics card than me, then you can download larger models. And then when you're finished, you can exit the container using exit and doas Podman compose down. So that is the pre-built containers that I've created for you. And the reason that I created those specific containers is because they all have different purposes to actually test stuff out. So we got the ffmpeg container with hardware accelerated video encoding using nvenc, a custom bin directory so that you can use my scripts, which is the default. I built this for me so that I could actually use my own scripts with hardware acceleration on FreeBSD, but you can also add your own scripts in there and they will show up in the container and then you can then run them. And what I'm now going to cover is custom containers. So let's come back to the root of the project, have a look at the gitignore file. Remember how to late at night. So the gitignore file is set to ignore all the env files that are created with the make file. It also ignores containers custom and all the bin and dot files directories. And this is so that the bin directories are for the scripts, or the dot files are for the persistent storage. So the bin directory on Firefox is for the Podman script, and the dot files are for the cache, the Mozilla, and stuff. And what this basically does is that ignores all the directories that are created by the make file for the persistent storage, so that when you do a git pull, you won't get any errors. Now the containers custom, right? So okay, containers. So you'll see there's no custom directory here. And that's because I'm not distributing it. It is a directory that you would create yourself. And what you have to do is follow the directory structure of the other things here. So as you can see here, we have a category, and then inside the category we have the application, which then has the Docker file, the make file, the compose.yaml file, and the env file. Okay, so what you would do is you create custom, okay, and inside here you would create you know, the name of the thing. So the Podman container you want to create. So for those that are called, it should be possible to actually create I mean, it is possible. It's just going to take a bit of work for me to do, but actually create a Podman container for DaVinci Resolve, for example. But this is, you would create a custom directory to create your own Podman containers that would not be tracked by Git. Okay, so what would be a sort of an application? Suppose you wanted to like something like Brave, the Brave browser or something. You're going to create a Podman container for Brave browser. You'd create the custom directory, and inside there you would create the Brave directory. And what you would then do is you can then copy the Docker make file and compose from Firefox into the custom Brave directory. And obviously you would need to read manuals on stuff. You have to understand Rocky Linux. So what you can actually do is, when you're searching for packages, you can enter a container and you can use DNF inside the container to search for packages, so you know the correct names for packages you want to install. But you would create you put in the Docker file, the compose file, and the make file to create everything. And you got to create this, you got to have this exact directory structure, because I'll just delete that now. We go into the compose.yaml file, for example, and we search for dummy-uvm.so. You can see it has a path to the dummy-uvm.so here, the base build dummy-uvm. So that's why you need to create the same directory structure, so that it will find the dummy-uvm.so file. All right. So you would create the containers custom, call it whatever you want, and add the Docker compose file, env file, the make file from one of the other projects. And as I said, the reason why I created those 4 different applications, as I said, is one, we got ffmpeg. We can check nvenc encoding is working with hardware acceleration and ffmpeg, ffplay with the audio. We then have Firefox, so that we can have a graphical application is launched using the desktop entry and the wrapper scripts with persistent storage and mapping directories with hardware acceleration, Widevine DRM, all stored so that we have a technique for launching graphical applications inside the container. So that's another thing to check out. Then WhisperX, which is important because that uses Python Torch, which uses Cuda. And if we can get that working, all the Python applications will work. As I said, text-to-speech, things like Comfy UI and Stable Diffusion for creating images and audio and video and audio, all that kind of stuff. And then we have Ollama, so that you can create your AI stuff, whatever it is, running your local models. And again, the Ollama will work from the FreeBSD side without any setup because we're using network host. And what that then means is you can use it with any front end on FreeBSD, which in my case is GPTel with Emacs. And as I showed you in a previous video, you can actually set up SeerXNG, the search engine in a Podman container, together with the MCP SeerXNG enhanced Podman container, which I've forked for FreeBSD, that allows the LLM to communicate with SeerXNG to provide it with search capabilities. Okay, so I did a video on that, which you can check out. And what that means is that you can run Ollama with Cuda in the Podman container, which then has access via the MCP server to SeerXNG running in the Podman container to enhance its knowledge and give it access to the web. Okay, so that's the reason I chose all those different pre-built containers, but also set the project up in such a way that you can create your own containers, which then won't be overwritten when you do a git pull. Okay, and if you want to be helpful and you have created some Podman containers in the custom directory, what you can then do is actually you could do a sort of git pull on GitHub on the project and say, okay, I've created these really useful containers. Could you add them to the project so that they're available to other people? I can then review them and actually add them to the project under a different category so that other people can benefit from your work. All right. So that was the kind of idea. That's one of the ideas behind the project, is actually, although it's complex, if it was easy, someone else would have done it. Okay, this wasn't a fluke, it wasn't an accident, it was planned, it was deliberate, because I know what I'm doing. If I didn't know what I was doing, then this wouldn't work. Okay, so the next thing is pruning old images. So as Podman images. And what you can see here is sometimes you get things like called none. And what you can do is you can actually remove these by doing doas podman rmi-a17, you know, the thing here. But you can also prune old images by running doas image prune-f. The other thing is what you need to do is understand how you upgrade the containers. So, for example, when there is a new version of Ollama and you want to build the new version of Ollama, okay, what you do is make sure, obviously, Ollama is stopped by running doas podman compose down inside the Ollama directory to bring the container down. You would then run doas podman rmi localhost / Ollama latest. So if we have a look here, what you will see is this is another thing that you need to understand. The name, so the name of these is set in the compose.yaml file. Okay, so we would run doas podman rmi localhost / Ollama latest. And you can see here tag is latest, so that's why you append latest. You're going to remove that. The reason why I'm giving you the instructions this way, do it this way, is because the image ID changes each time. Okay, so by doing it this way, you can ensure it's actually deleting the container. So that's how you delete the Ollama container. Same thing for the Firefox container, the ffmpeg scripts, the Whisper, and this is how you delete the base image. This is the base image that you build, whether it's Wayland or X11. And the reason why you want to actually delete the containers is because you need to delete them because you're going to build a new version. So, for example, deleting the Ollama container. So you would delete the Ollama container, right? AI Ollama, build the Ollama container. So remember, you don't really need to delete the base image. Okay. Again, the base images are the Wayland or X11 ones. You don't need to delete that. But if you want to build the latest version of Ollama, you delete the old version. And what you do here is don't edit the text in the README file, okay? Because otherwise it will be overwritten. You'll get an error with Git, so you would copy that there. And suppose Ollama 25 comes out, you just change the version number, right? And then in the Ollama directory, you then run that command, and that would then build the latest version of Ollama, which does take a while to pull down. It's a 1.2 gig file or something. So again, what you do, view logs, let me just check. Bear with me while I find the view the logs. Okay, so when you're actually building it, it should give you a progress report, but if it's not, you can actually just view the logs for the progress. So that's how that's why you would delete the container and then rebuild it. Okay. So yeah, a bit of a marathon one, almost 3.5 hours. So it took so long, but I have to take you from knowing nothing to actually get it all built, and that requires you understanding how to install Podman, configure all the settings required for Podman, fstab, devfs.rules, pfconfig, and then actually building everything and having an understanding of how everything works, so that you've got the ability to build your own containers, right? Because that's one of the goals is, yes, I can create containers for you, but there's only me, a cup of tea, and a packet of biscuits. There's no team of monkeys working away, knocking this shit out. There's no AI slop. It's all just me. So yeah, I can create containers that will be useful. But at the same time, if there's a community of people who are actually going to find this stuff useful and build their own containers, they can then submit them to the project so that other people can benefit. So what I'll do, as I said, is come across to the project. The So what I'm sort of thinking is the various ways you can sort of get involved. One, obviously, you can just leave a comment under a video, but that's not really great for long conversations or, technical stuff. So, leave a comment if you want. But basically, the GitHub repository would be for issues, not so much, wouldn't be designed for, I'm trying to do this and I'm stuck. It would be for raising issues or for pull requests, such as I've created a container for this browser or this application. Can you review it and add it to the project? In which case, then I'll have to go through a process. But what you'll need to do is actually follow the way I've set stuff up. So you will have to follow the way I have formatted stuff exactly for it to be sort of accepted. And you will have to know what you're doing and not just generate something with ChatGPT. It's okay to use sort of AI for troubleshooting and searching and bug fixing, but generally just creating an entire thing that you don't understand how it works isn't good, because you then are at the mercy of the AI, as opposed to actually having critical thinking of how to actually debug things and build things efficiently and elegantly, as opposed to just some shit code that's churned out by an AI. So quick sort of queries or stuff, YouTube, issues and pull requests would be for GitHub, and I'm also on the FreeBSD forum. There we go. Okay, so what I will actually be doing is posting this under how to's and moderated, so you can see me here. So what I'll actually do is, once I've uploaded the video and completed the README, made sure everything's okay, I'll be posting the video and link to the documentation and everything on the FreeBSD forums. So if you want a in-depth chat, or you're actually stuck on actually getting things working, or you want help building your own containers, that sort of thing, this would be the place that would be best suited for that, because you can have a long conversation, hopefully not too long, because the more time I spend sort of having to troubleshoot or guide people through, the less time I got to build things. So but yeah, this would be the best place to actually do things like I could set up a poll, for example, on containers that people want built. So whether it's AI stuff or things like Kokoro, which is for text to speech, or different browsers or different GUI applications. I could create a poll, and then then I can sort of build either command line or GUI application containers. And as I said, the advantage of this is, as I said, if I come across to here as an example, repositories. Okay, I'll show you why this is substantially better. Okay, so this is DaVinci Resolve FreeBSD Gel Rocky. I created a couple of years ago. Now, this works, okay? But the disadvantage of using a jail is you have to manually create the jail. You've got to enter the jail, run lots of commands manually, okay? Inside the jail, okay? You've got to enter the jail, got to manually run DNF update, install things, create directories, all that kind of stuff, right? And it's possible that works, but it's not the most user-friendly way of doing things. So the advantage of us using Podman is that it's distributable. You can distribute the applications and download them. And as the reason why I'm not doing images that you can directly pull down is because the way the project is designed is that you build them locally and it will use your username and ID and everything so that the user in the Podman container is the same user as on the FreeBSD host, so that when you share files and stuff between them with the mounted directories, that they're owned by the FreeBSD host. Whereas if we had a image that you pulled down, it would just be something like user Podman or user Rocky, and you would then have issues with having to change model the files. Okay, so that's why I'm doing it this way, not having images that you pull down, that you have the configuration files, okay, that you then build the images from. So I know that's been a long one, 3.5 hours, and I'll have to upload this, and it's 1:15 in the morning. But yeah, I thought it was probably a good time to do this because I know that this is going to take a long time to upload this video, so I'll have to upload it overnight, and hopefully it'll be, I've got to then finish off a bit of the documentation and then wait for the video to upload, then do the description for the video, and then do the post on FreeBSD forums and put the link to the video and the documentation and all that kind of stuff. So yeah, it takes a lot of work, put it mildly. And I just wanted to give you some insight into the actual process that I went through, of my knowledge of building jails to run applications with Cuda. And as I said, the advantages with the jail, what you had to do was you had to manually install the exact same driver in the jail as on the FreeBSD host, and then if you upgraded the driver on the FreeBSD host, you had to uninstall it in the jail and then install a new version. So there's a bit of a catch up. Whereas this version does exactly the same thing, but better. Okay, it's a better system, and to actually come up with the idea to do this wasn't easy. It took a lot of thought and a lot of knowledge across many different subjects: shell scripting, make files, devfs groups, sockets. So it is a big thing because it now enables Cuda on FreeBSD, which we didn't have before. And we have Cuda, and we have the equivalent of the Nvidia toolkit to allow containers to have access to the GPU. So as I said, not only are we, well, I'm saying we, you didn't have nothing to do with it. I'm just being polite. But yeah, basically bringing Cuda to FreeBSD, and what that means is we now have access to many more things than we did previously, and that includes hardware accelerated video encoding, different applications, Widevine DRM with Firefox without having to use any hacks, and like there's things like, I think it's called the OpenVM project or something, which is like some hack where you kind of got to get a binary file from an Android device, which means downloading sketchy files from the internet. There is the foreign CDM project by the same guy who actually does the dummy-uvm.so file. But that only works with Chromium, and the issue with that is that Chromium doesn't support the manifest v2 extensions such as uBlock Origin, and so you can only run uBlock Origin Lite with Chromium, and that doesn't block the adverts in videos. We don't want adverts in videos, nothing more irritating. But yeah, I'm just babbling on a bit at the end here. But basically, what this project means is that FreeBSD is now the equivalent of Linux, in that we can run all the things that weren't possible, all the AI tools, all the Python applications, anything that, things that required Torch, as I said, Stable Diffusion, Comfy UI, without virtualization. So this is native performance, and we have maximum compatibility because we're using Rocky Linux 9.3, which is the same as the Linuxulator on FreeBSD. So there's no issues with any compatibility issues between the Linux side and FreeBSD, and we're using this technique that I come up with, where I just thought, okay, so when you install Nvidia, it requires Linux that installs the Linux libraries in compact. Couldn't we just mount those compact directories into the container, expose the GPU, and that should make the container think it's using the GPU? And yeah, said it works. But took a long time to actually get it to work and figure everything out, and then do the project, the documentation and the video and all that palaver. And yeah, it's free as in beer, so there's no monetization on YouTube, no adverts, no donations, no trying to sell you some merchandise, none of that. Totally free. I don't make a penny off it. But Nvidia, you've got deep pockets. I'm sure if you want to sling a few quid my way, I wouldn't object, but I don't think that's very likely. So yeah, sorry for rabbiting on for so long, but there's a lot to get through and a lot of knowledge that you need to understand in how the project works and how this was all built and conceived and designed, so that you can actually use it and create your own stuff. And if you want, contribute back, and that way we can actually have a list of different kind of categories of applications that can be distributed and easily pulled down and built, as I said, either GUI or command line applications. So I better go and feed the cat, because otherwise it's going to start tearing the carpet up. But yeah, I'll upload the video, and I know that's going to take all night and leave the computer chundering away, making the room even hotter than it already is in this searing heat, and keeping me awake with the fans and the lights. But there you go. What are you going to do? So I'll put links to all this under the video. I know it was a long one. You managed to stick around. Thumbs up. But as I said, it was a lot to get through and to explain and to actually kind of pass the knowledge on of how this all works. And as I said, if this was easy, then someone else would have thought of it, but they didn't. And it's one thing about having an idea, and it's another thing executing it. And you should have been able to see how many challenges I actually had to overcome to get all this working. So it's not like one or two little fixes, multiple independent fixes that then fix other things that fix other things. And so, yeah, requires a lot of thought and knowledge across multiple things and different ways of looking at stuff. As I said, even things just like launching GUI applications where you can't use doas Podman exec because it then runs the application as root that then breaks the access to the GPU. But then I thought, hang on, containers are jails. So then we can run jail commands on Podman containers that then fixes that issue. And then coming up with scripts to launch applications and desktop entries and all that kind of palaver. So, yeah, involved, put it mildly. But I know it might seem a bit overwhelming, but once you actually get Podman set up, it doesn't actually take that long to get these applications working. And you'll then have access to stuff that you didn't previously, which is a good thing. It just means that you can now use Cuda on FreeBSD, full hardware accelerated video, Python applications, GUI applications, command line applications, anything. And I've got a method for actually bundling stuff together and being able to distribute it. But as I said, I will put a post up on the FreeBSD forum that I'll then link to in the video, so that you can either have issues on GitHub or pull requests for containers you've built, or if you're getting stuck on something, or you want to suggest a container to be built, you want me to build that sort of thing, then the FreeBSD forum would be the best place. I'm also on Reddit, but I never use it because every time I post on Reddit, it gets blocked by the automatic filtering for some reason. God knows why. But yeah, FreeBSD forums would be the best place for more sort of involved chats. But yeah, the other reason I'm kind of going into it in such depth is so that I don't have to respond to so many comments. No, I don't mind responding to comments at all. Not that I get many anyway, but it stops like a lot of how do I do this? Why is this not working? Etc. Etc. You can refer to the video, and as I said, I'll have to put. That's the other. Oh God, that's the other thing I'll have to do. I'll have to go through and watch the video and put all the timestamps and all that palaver. So that's going to take even more time. Great. So that's all for now. I better get the cat some food. So yeah, I'll stick links to all this under the video. Upload the video. Hopefully be uploaded. God knows when. If I start it now, probably be about 20 gig or something in file size. A bit. And not having a super fast upload speed, that's going to take forever. But yeah, I thought it'd just be better to do it overnight, so that hopefully it'll be, a good weekend project for you, rather than, being out in the sun and, what do you want to do that for when you can sit in front of a computer in a darkened room? Much more fun anyway, isn't it? So that's all for now. So yeah, basically, long and short of it is we've now got Cuda on FreeBSD, as well as lots of other stuff that wasn't previously possible. And that's all for now. I think too late to drink any more tea, and yeah, that's why I don't like the hot weather. Interferes with my tea drinking. So yeah, I'll go and feed the cat. Make sure it's not killed anything. dragged some poor animal in somewhere. But anyway, that's enough babbling on rather. I need to get some kip, and I'll leave it there.